So now we are discussing 2019 A-level paper from here. First of all, we'll be discussing MCQs, and then we'll start discussing structured essays, and the next session will be the discussion of the essay paper of 2019 paper, right? So then 2019 is the first paper. 2019 is the first paper of advanced level new syllabus of your syllabus. It is the very first paper, right? Okay, so then here in 2019 paper, when we get first 10 MCQs, you can request the MCQs for the discussion, right? Please check your marks and request the MCQs for the discussion for this paper. Give 1 minute. So this is 2019 paper, and here mark scheme. So I have sent you the answers here and the mark scheme. So then there are some questions that we get answer number 5, right? So for 37, answer number 5, the reason is ABC, right? ABC. 37, answer number 5, the reason is ABC, correct? Mention that. Okay. Apart from that, the answers are correct. So you can put your marks out of 10 for the MCQ paper. You have 1 to 10. There are 10 MCQs. So you can put your marks for this 10. Again, 11 to 20. Right. And then 21 to 30. Likewise, out of 10, you can put your marks for each and every category and take the marks out of 50. Right. Take the marks out of 50. So what was your final mark when you consider out of 50? Right. That's the MCQ score. Right. Other than this, first of all, send me the difficult MCQs. Right. I mean here, question 1 to 10, the suggestions to discuss the numbers. For the question 4, they have given all. It's a error in the Tamil medium paper. Otherwise, the answer is 3. Right. For question 3, question 4, we can take answer as answer number 3. Right, let's start the discussion. So then I have requested the questions. Right, and the questions 1 to 10 I'll circle your question number here, and it's easy to discuss. Question number 8, we have to discuss 5, 7, right? Furthermore, okay, we'll discuss this. First of all, question number 5. So then when we are moving to question number 5, this is question number 5, right? Identify the pair of elements which has the largest difference in electronegativities, right? Largest difference in electronegativities. They are asking identify the pair of elements. Right. So in a case like this, they're giving a period table in your paper, right? So then you can write the elements like this. Lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, argon, and it is potassium, then calcium, right? Largest difference in electronegativities, just circle these elements. Boron, we have aluminium, we have beryllium, okay, and then silicon, carbon, right? These elements. Then when you consider this species, what we can understand, largest electronegativity difference. Now we know this is question number 5 discussion. Question number 5 discussion. Electronegativity is increasing across the period. Electronegativity is increasing across the period. So then downwards the group, electronegativity is decreasing. So from the given elements, the highest electronegativity is available for carbon. From the given elements, the highest electronegativity is available for carbon, isn't it? Beryllium, boron, and carbon. From the given elements, the highest electronegativity is available for carbon. Then for which element the lowest electronegativity is available? Move downwards group. So when you move downwards group, you will find the electronegativity is getting decreased. So then we have aluminium and silicon. So from aluminium and silicon, which one is having the lowest electronegativity? We know across the period, electronegativity is increased. Right? You can remember fluorine's electronegativity was the highest value. Right? Fluorine's electronegativity was the highest value. So because of that, we can say when you consider aluminium, this is having lowest. So you can comment on that. Okay? Just write a small comment, lowest, and then this is highest. Right? I mean, when you are writing a review for all the MCQs, this will be very useful. Right? So then carbon and aluminium. The answer is answer number 5. Right? Just raise your hands if it's clear. The answer is answer number 5, highest and lowest. We should select the highest one. We should select the lowest one. Then we'll be getting the highest difference. Right? Highest difference is available there. Okay, good. Next question. That is question number 7, I think. Yes. So you're asking to discuss question number 7. Incorrect regarding benzene. Incorrect regarding benzene. So then first of all, related to question number 7, related to question number 7, you have to understand what is incorrect. Okay? So when you draw the structure of benzene, which structure is correct? And benzene structure mana structure is correct, right? We can draw benzene like this. This, and then this. These are Kekulé structures. This is not the real structure of benzene. Actually, the real structure of benzene is the resonance hybrid. It is not having double bonds, it's having partial double bonds. This is the real structure of benzene. Resonance hybrid. Right? Resonance hybrid is the real structure. Keep remember that. So now in this question, right? In this question, 2019 A-level paper, MCQ, question number 7. The resonance hybrid of the benzene is depicted as follows. So then they have given 2 different resonance hybrids, right? Not a resonance hybrid. Generally, resonance hybrid is only one single structure, right? So we can't draw 2 resonance hybrids. For one single molecule, how we draw 2 resonance hybrids? Okay. This question is, the first statement is incorrect from the beginning. The resonance hybrid of benzene is depicted as follows. They have given this 2. It's incorrect. You can mention these are Kekulé structures. Okay. These are Kekulé structures, and then these are not the resonance hybrids. These are called resonance structures, RS, and this is called RH, resonance hybrid. What is the difference between resonance structures and resonance hybrid? Resonance structures are the structures that can be existed or that can be available for a certain molecule, certain ion. That can be stable or destable, right? Stable when not Coulomb, destable when not Coulomb. But when you consider the resonance hybrid, it is the actual structure of the molecule. Actual structure of molecule. Let's keep remember carbonate. So for carbonate, you can draw these figures, right? Keeping the pi bond here, getting the pi bond here, getting the pi bond here. Those are resonance structures. What is resonance hybrid? Okay. Resonance hybrid means the actual structure of carbonate making partial double bonds here and there, right? Can make the partial double bonds like this. So then this is minus half, right? Minus 2 over 3 for carbonate, minus 2 over 3, minus 2 over 3, minus 2 over 3. Can you understand? This is what we have to know. Right? So then the first statement is incorrect. Second statement, all 6 carbon atoms of benzene are sp2 hybridized. Yes. Then as we have trigonal planar shape, we know inside benzene, around each and every carbon we have trigonal planar shape, that is sp2 hybridized. It is true. sp2 hybridized, sp2 hybridized, sp2 hybridized, sp2 hybridized, and here also sp2 hybridized. Right? Just know the geometry here, there's a hydrogen here. And there's a carbon-carbon double bond. I think you can understand. Here, trigonal planar shape, right? sp2 hybridization. All bond lengths between any 2 carbon atoms of benzene have same value. Incorrect. We can't say in benzene all bond lengths are same. Okay. All bond lengths between any 2 carbon atoms of benzene have the same value. Yes, that is correct. That is correct, right? Because in benzene, all the bond lengths are exactly same as it is having partial double bonds. If you are considering benzene as the resonance structures or the Kekule structures, sometimes you may think in benzene we have carbon double bonds, carbon single bonds, so then the bond length may be different. No. Benzene means resonance hybrid. Benzene means resonance hybrid. So in resonance hybrid, actually what we have the partial double bonds. In resonance hybrid, we have partial double bonds. Clear? Right. Then all carbon-carbon and carbon-carbon hydrogen bonds of benzene have the same value. What do you have to say? Carbon means, right? This carbon. You can think it from resonance hybrid or resonance structures. Any structure is okay. Here the bond angle is 120. Here also the bond angle is 120. Here also the bond angle is 120. Then we have the same bond angle as it is trigonal plane. That's true. All the hydrogen atoms in benzene lie in the same plane. Benzene is a planar molecule. All the carbon atoms, all the hydrogen atoms, they are lying in one single plane. Right? A planar molecule. Entire benzene ring is a planar molecule. All the carbon atoms, all the hydrogen atoms, they are lying in the same plane. Is it clear? Right. That is very important. So then the statement 2, all the bond lengths between any 2 carbon atoms of benzene have the same value. Okay. So then that is true because the carbon-carbon bond lengths are exactly same as it is having partial double bond character. Right? Benzene in actual. In benzene, what are the actual bonds? Those are not double bonds. Those are partial double bonds like this. Right? Partial double bonds like this. Today, we have partial double bonds. Should understand. Right. So we have discussed 10 questions from there. Right? 10 questions from there. And then that is question number 7. Answer is answer number 1. Right? Okay. Next one. What we have discussed. That is question number 8. As usual, a physical question. Right? Okay. What was your answer for question number 8? Okay. I'm going to discuss this question in the board. Question number 8. Right. It is related to chemical calculations. It's not that much difficult. Actually, we can attend the question without an issue. Titanium chloride reacts. titanium chloride reacts with liquid magnesium to give titanium metal and magnesium chloride. Just read the question. At high temperature, when 0.95 grams of titanium chloride, kilograms, we have to convert to grams, it would be 950 grams, made to react with 9.72, 97.2. This will be well simplified with this value, right? No need to worry about that. And reactant is, so they are asking the reactant that is completely consumed. It's called limiting factor. They are asking the limiting factor here. And then the amount of titanium metal found out. Right. First of all, what do you have to do? Initially, we have to read the question. We have to read the question, right? And then write the reaction. We have to write the reaction. So then first one, TiCl4 reacts with magnesium to give titanium metal and magnesium chloride. Titanium metal and magnesium chloride. Right? Yes. So then we have to balance this. So then here we have 4 chlorines and put here 2. Then there's 2 magnesiums, there's 2. Likewise, we should balance the equation from the beginning. We have to balance the equation when we start. Right. Now then we should write the number of moles. Titanium chloride 950 grams should be divided by the molar mass of titanium chloride. Actually, the molar mass of titanium chloride is 190 grams per mole. So 19 times 5. There's 5 moles here for titanium chloride. Likewise, when you get magnesium, the magnesium initially it is 97.2. We are applying N equal to W over N. Right? 97.2 grams divided by 24.3 grams per mole. 97.2 should be divided by 24.3 grams per mole. That is 4 moles. Right? So we have 4 moles and we have 5 moles here. Right? So what we have to understand? First of all, we have to find the limiting factor. What is limiting factor? The species with the lowest number of moles. The species with the lowest number of moles. So from these 2 species, which one is the species with the lowest number of moles? Is it titanium chloride or magnesium? It's magnesium. Then just think magnesium is the limiting factor. Right? Just think magnesium is the limiting factor. So then in that case, we have to forget these values. Right? So when magnesium is the limiting factor, we should consider this entire 4 moles will react. So then this 4 moles will react with respect to this 2, and then it will become 0. Right? That's the limiting factor. So you can understand with respect to this 2, if it is reacting 4 moles, okay, I mean the stoichiometric numbers are proportional to these moles, reacted moles. 2 is proportional to 4. So then with respect to 1, what should be the reacted amount? What should be the reacted amount? With respect to 2, if 4 moles is reacting, with respect to 1, what's the reacted amount? Yes, it's 2 moles. It's 2 moles. So then you have to see whether that 2 moles is available in titanium chloride. So actually it is available. When you consider titanium chloride, now here you can see we have 5 moles. So then what we have to do, we have to react 2 moles from that, right? As it is suggested by this. Then this would be the limiting factor, right? So 4 is proportional to 2 with respect to 1. The reacted amount should be 2 moles. Initially we have 5 moles. So then 5 minus 2, it is 3 moles. It is 3 moles. So then you can get the amount of titanium produced. The amount of titanium produced from this. Right? So then what is the produced amount? You can see when 2 moles of magnesium is reacting, we get 1 mole of titanium. You have to think everything from magnesium. Now when 2 moles of magnesium is reacting, it is forming 1 mole of titanium. So when 4 moles of magnesium is reacting, it is forming half of that. It is 2 moles of titanium. Right? So now we have selected the limiting factor, magnesium. Then we have to get the mass of titanium. So then how to get the mass of titanium formed? Mass is equal to number of moles into molar mass. So then 2 moles should be multiplied by molar mass. What is the molar mass of titanium? It's 48. Then the mass will be 96 grams. Right? 96 grams. So then here we have expected the answer as answer number 2 in question number 8. So I have discussed the questions that you have suggested from question 1 to 10. Are there more questions to discuss in 2019 A-level paper? Question 1 to 10. 1 to 10. Right? I think question number 10 is very simple. Conductivity. Right? Question number 10. The answer is answer number 4. Question number 9 is just substituting the units. Right? Substitution for units. Question number 7, we have discussed. 6 is shapes. Right? Very simple. You have to draw the shape and get the answers. Third one is resonance structures, resonance hybrids. So for oxalate ion, you can draw resonance structures and see how many resonance structures are available. So for question number 2, the answer is question number 3, the answer is answer number 3, right? 4 resonance structures we can draw. So it's a good paper, 2019 A-level paper. We have discussed first 10 questions, right? Any more questions to be discussed? Second එක discuss කරන්න කියලාද මේ කියන්නේ? Okay. Right, question number 2 එක discuss කරන්න කියලා තියෙනවා. So what is question number 2? This one is question number 2. Right. කමක් නැහැ. ප්‍රශ්නයක් නැහැ. ඕන statement එකක් එවන්න. Maximum number of electron pairs of an atom are associated with principal quantum number n equal to 3. Right. Maximum number of electron pairs. Electron pairs maximum ගන්න අහන්න. So what was your answer? Right. Question number 2 we're going to discuss. Very simple. N equal to 3. So we know N is the main energy level. N is the main energy level. It is called main quantum number. So when N is equal to 3, we know sub energy levels or L values, right? Then what are the sub energy levels? 0, 1, 2. 0, 1, 2. So 0 means it is 3s. Okay. 1 means it's 3p. 2 means it's 3d. Right? So in S subshell, how many electrons are there? Maximum number of electrons. When in S subshell, the maximum number of electrons is 2. In P subshell, the maximum number of electrons is 6. In D subshell, we have 5 orbitals. In one orbital, it's 2 electrons. Right? In one orbital, it's 2 electrons. Then orbitals පහක් තියෙනවා in D subshell. Right? 1, 2, 3, 4, 5. In P subshell, there are 3 orbitals. In S subshell, there's only 1 orbital. In each and every orbital, maximum number of electrons that can accommodate is 2. So then here 2, here 6, and here 10. Right? So what this question is asking? Question එක අහන්න මොකද කියලා පොඩ්ඩක් බලන්න ඕනේ. Maximum number of electron pairs that an atom can be associated with principal quantum number n equal to 3. Right? So then electrons 2, 6, 8, that's 18. Then n equal to 3 වල තියෙන පුළුවන් maximum electrons ගන්න 18. හරි. සමහර කෙනෙක් 18 මාක් කරලා තියෙනත් පුළුවන්. 18 නෑ වෙලාවට. හරි. They are asking pairs. Right? So if the maximum number of electrons is 18, the electron pairs is 9. Right? Electron pairs is 9. Very simple. ඊට ගොඩාක් අමාරු කොට number questions අහලා තියෙනවා exam එකේ. Right? So then when you consider n is equal to 3, we have 3 subshells. 3 subshells is 0, 1, 2. So then 0 stands for 3s. In 3s, we have 1 orbital. In 3p, we have 3 orbitals. In 3d, we have 5 orbitals. Keep remember that. Clear? Yes. So then the answer is answer number 5. So then it's another request to discuss question number 8. I have discussed question number 8 already, right? Okay. Right. So then that we have discussed question number 5, 7, 8, and then that question 2 is also, right? Okay, next one, starting from question number 11 to 20, what are the suggestions to be discussed? Right? 11 to 20. Then please request if there's any issues with the questions. So you can check your marks for 11 to 20 from here, right? Then put out of 10 for 11 to 20, and then you know what are the difficult questions, what you have missed, right? Please suggest those questions. Right. හරි questions ටික එවනේ. ඔව්. දැන් අද current එකත් මම හිතන්නේ යන්නේ නැහැ කොහෙද. එක්කම මේ paper එක attend වෙන්නේ නැත්තේ තනිපෙන. හරි. ඇඟිට ගන්න බෑ. එක්ක paper එක කළා. ඔය reasons දෙක තමයි තියෙන්නේ. මෙහෙමයි exam එක තියෙන දවස් වෙනකන් ගොඩක් වැඩ කරගෙන යනවා. සමහර අය හිතන syllabus එකක් කව වෙලා තියෙන papers ටික use කරා මොකක් හරි කළා class එක මේ මම balance කරගන්න එහෙම කියලා හිතනවා. අපි අන්තිමට එකේ තමයි හොඳටම වැඩ කරන්නේ. මම තව ඇඩිෂනල් ක්ලාස් එකක් ක්ලාස් එක කරනවා. ඒකත් ඔන්ලයින් ක්ලාස් එකක් තමයි. කොහොමද මේ ක්ලාස් එක ෆිසිකලි මම තියෙනවා. අවුරුදු දැන් මම ක්ලාස් එක ෆිසිකලි කරන්න නැහැ කියලා මම ක්ලාස් එක ෆිසිකලි කරනවා. ඒක හරියි. එක්සෑම් ඩේට් එක දෙන්න කියන්නකෝ. මෙන්න මෙදාට එක්සෑම් එක හරියටම තියෙනවා කියලා. ඊට පස්සේ මම මගේ ප්‍රෝග්‍රෑම් එක කියන්න. මට මේ කියන්න ඕනේ දේ අපි තව ක්ලාස් එකක් ඇඩිෂන් එකේ තියමු. ඒකෙදි live questions discuss කරමු. I mean we don't give questions previously. We will be giving questions live. Now you can do field distance. Like a live performance is required, right? මතලේ live class එකට ඔයගොල්ලන්ට පුළුවන් time එකක් ගන්නවා. Like 2.5 hours per දෙකමාරක් විතර මේකට additional. ඒකෙදි අපි එවල questions විදිහට discuss කරන්නේ. මම questions අහනවා. හරි. revise කරන්නේ, colors ගන්න. ඒ වගේ අර අපි full syllabus මතක් කරන පොඩි rapid revision එකක් වගේ යනවා. physical, general හැම එකක් කරන්නේ class එකක්. මම එහෙම එකක් හිතලා තියෙනවා හැමෝටම කරා. ඉතින් ඔයගොල්ලන්ගේ memory එක check කරනවා notebook බලලා හරි කමක් නැහැ හරි. හැම තැනකීම අපි questions ටිකක් discuss කරගන්නේ conversions හරි මේ හැම area එකක්ම cover වෙනවා. ඉතින් ගොඩක් අර memory එක වැඩි කරගන්න තමයි මම හිතන්නේ. නම්බර් මම අහන questions වලට answers දෙන්න පුළුවන් කියලා මම questions පහක් අහන්නේ. Number 1. What are the products of the decomposition of magnesium nitrate? When magnesium nitrate is decomposed, what are the products? Just think 10 seconds. If you can give the answers, you are having a proper memory. If it is impossible, you should study or you have to study the inorganic notes again. This is the answer. Magnesium nitrate is decomposed to give magnesium oxide, NO2 and O2. Next question. What is the color of cobalt tetrachloride? COCl4 2-. So then, you know, if you could remember the answer from your mind, okay, then what you have to do, if there's any mistakes, if there's any issue, try to study our inorganic short note. කලින් ක්ලාස් එකකත් එහෙම ප්‍රශ්නයක් වෙලා මම කිව්වා මගේ short notes හතරම බලන්න. මේ group එකට ටැග් කරන මගේ short notes හතර ආයෙ පාරක්. හරි. General, inorganic, organic, physical, we have 4 short notes. You can just take the short notes from our coordinator. I'll make it available and inform you, right? Then just watch those 4 sessions. Just like 8 hours, we can cover everything. Entire session is explained, right? Blue color, dark blue කියලා සමහර අය කියලා තියෙනවා. Blue color, right? COCl4 2 minus, it's blue color. Next question. What is the relationship between Kp and Kc? The relationship between Kp and Kc. Third question. Yes, so you can keep remember. What is that? It is Kp equal to Kc RT delta N. This bracket is very important. This bracket is very important. Today, Kp equal to Kc RT delta N. The bracket is very important. And delta N is the products, the gaseous products minus gaseous reactants. From the gaseous products, you should subtract gaseous reactants. That is delta N. Is it there? That's also really important. Okay. And then my last question here. In the sodium hydroxide production, for the anode chamber and for the cathode chamber, we have got 2 reagents. What is the reagent we are adding to the anode chamber? And what is the reagent we are adding to the cathode chamber? I am asking raw materials. Production of sodium hydroxide, membrane cell process. So just check whether you can answer these questions. So I'm asking from full syllabus. මේ වගේ එක session එකක් live තම week එකටම කරන්න දැන් මම plan කරගෙන ඉන්නවා. අර බලමු උදේ පාන්දර හරි රැය වෙලා හරි. ඔයගොල්ලන්ට අනිත් class එක clash වෙන්නේ නැති time එකක් හැමෝටම වෙන්න පුළුවන් time එකක් මම ගන්න try කරනවා. right? ඔයගොල්ලෝ මේ session එකේ සමහර අය recording එකක් බලනවා. Okay, මේක තමයි answer එක. In sodium hydroxide production, see our industrial session, membrane cell for the anode compartment. For the anode compartment, we add brine, okay. Sodium chloride. Concentrated sodium chloride should be the answer. Okay. එහෙම නැත්නම් brine කියලා කිව්වත් ප්‍රශ්නයක් නැහැ. For the cathode compartment, what we add? මම කියන්න බලන්න cathode එකට add කරන්නේ මොනවද? Yes, some of the students have given the answer. Actually, for the cathode compartment, we have to add water. දැන් මේව මතක නැති අය ඉන්නව නේද? අන්න. හරි. exam එකට කලින් දවසේ පාඩම් කරන්න බෑ මේව. දැන් ඉඳන්ම පාඩම් කරගන්න. කොහොමද පාඩම් කරන්නේ? ඉතින් video sessions මේ හැම එකටම තියෙනවා. ඒ ටික බලන්න, කොළවල ලියන්න පාඩම්. මම questions අහනකොට ඇත්තට මතක් වෙයි පුළුවන් ද බැරිද කියලා. මේකයි මම කියන්නේ. මම ඊළඟ question එක. මම තව questions දෙකක් අහනවා. අහන්න ආසයි questions. මොකද ඔයගොල්ලන්ට ආසයි answers දෙන්න මට ආසයි questions අහන්න. මට full syllabus ඕන තැනක් මතකයි. When we add sodium borohydride to carboxylic acid, what is the product? Is there any product? You can say yes or no. If there's a product, you can mention the name of the product, like alcohol, aldehyde, ketone, primary alcohol, secondary alcohol. But first, my question. When we add sodium borohydride to carboxylic acids, what is the product? Okay. Yes, the answer is no product because carboxylic acid doesn't react with sodium borohydride. Yes, that's correct. Next question. When we add lithium aluminum hydride to carboxylic acids, what is the product? Specifically say the product. This. Very good. So now you have a good memory. මෙතන ඉන්න answers දෙන අයට නම් හොඳ memory එකක් තියෙනවා. but සමහරක් අය මට හිතෙනවා මේව මතක නැති අය ඉන්නවා. හරි. මම එහෙම classes වල දැක්කා. ඒකයි මට මෙහෙම අහන්න හිතුනේ. ඒගොල්ලෝ කිව්වා පාඩම් කරලා එන්න මම ඊළඟ දවසේ ආවම දවසම අහනවා ඔය වගේ questions කියලා. හරි. class එක ඉවර වෙනකම් අහනවා. ඒකට පුළුවන් මතක් කරගන්න. හරි. So actually carboxylic acids. So therefore carboxylic acids when we are adding lithium aluminum hydride, this at third floor it is reduced into the first floor. It's passing aldehydes. It is primary alcohols. Primary alcohols. Okay. So for primary alcohols, if we add PCC, what is the product? For primary alcohols, if we add PCC, what is the product? That's aldehyde. Okay, that's enough, ne? Alright, this is okay. Good. Ochcha ahanna puluwan. හොඳ යාළුවෝ දෙන්නෙක් සෙට් වෙලා ඔය වගේ යාළුවෝ questions අහගන්නම පුළුවන්. හරි. දැන් මම මේ කියපු ළමයි දෙන්නා ගෙදර twins ලා. දෙන්නම science කරන්නේ දෙන්නම chemistry කරන්නේ. right. ඉතින් questions අහන්න බැරිද? එක්කෙනෙක් අහනවා අනිත් එක්කෙනා කියනවා. අහනවා කියනවා. හරි. වගේ quiz round එකක් යන්න පුළුවන්. ඉතින් හොඳට memory එක check කරගන්න පුළුවන්. මම යාළුවෝ දෙන්නෙක් උනත් zoom session එකක් දාලා එහෙම වැඩ කරන්න පුළුවන්. මම මේ questions ටිකක් අහන්න මම answers දෙන්න. හරි. so මම අහන්න බලමු මේ lesson එකේ ටික පුළුවන්. මම ඇත්තටම මෙහෙම points 1000ක් විතර questions 1000ක් විතර හදන්නේ බලමු මම ඒක time එකත් එක්ක කරගන්න ඕනේ මේ අවුරුද්දේ කරන්න හදන වැඩක් theory ටික memory plus කියලා program එකක් බලමු හරි alright that's my plans so then actually having a better knowledge related to that part so then what's my advice please do not plan chemistry in upcoming weeks because we are trying to actually we have planned everything you just have to follow it මේ දවස්වල මේ ටික විතරක් කරලා ඉඳ පේපර් එක කරලා MCQ රිවිව් එක ලියලා ඊළඟ පේපර් එක ලෑස්ති වෙන්න. මේ ටික ඇති. මම උගලට additional sessions බලන්න ඉන්න අයට term test paper discussions ටික group එකට add කරනවා. Devi Royal Visakha term test discussions. Video discussions. right? මම ගිය අවුරුද්දේ papers ගිය අවුරුද්දේ discuss කරපු ටික ඔයගොල්ලෝ මම දෙන්න හදන්නේ. එක week එකකට එක session එක ගන්න වගේ add කරනවා. paper mark scheme video discussion. okay? yeah additional ඕන. තවත් වැඩ කරන්න තව ගොඩක් කරන්න ඕනේ. අපි දන්නවා සමාජ සුරක්ෂා හිතනවා. ඒ අයට support එකක් විදිහට තමයි මම ඒක දෙන්නේ. right in our class my main target is covering 2021 pair right 19 20 21 then after that I'll explain the next process okay so from question number 11 to question number 20 what are the questions we have discussed we have sent some questions I'm going to check them okay I'm going to make a circle කරන්න හදන්නේ 14 15 18 12 හරි 19 17 right මේ කවුද මේ 11 12 14 16 හරි okay වෙලාවට questions දෙකක් නෑ හරි දෙකක් තියෙනවා නේද okay so then I'm going to discuss this මෙන්න මේක discuss කරලා දෙන්න හරි question number 11 12 මම මේක ඉවර කරා මෙන්න 11 what is the question so then for question number 11 the answer is answer number 4 why the answer is answer number 4 correct answer when the chemical species SO2 SO3 SO3 2 minus SO4 2 minus and HCl2 are arranged in the increasing order of electronegativity of sulfate right actually how to attend the question you should know electronegativity will depend on three factors the main question එක විනාඩි දෙකක්වත් යනවා කියලා තමයි මම හිතේ right electronegativity will depend on three factors hybridization charge and oxidation number electronegativity means ability to attract electrons so when I'm telling this you can write the things right and මම මේක කියනකොට අර මොන හරි ටිකක් කකා මේක popcorn එකක් වගේ මේ TV series එකක් වගේ බලන එක නෙවෙයි මම මේ කියන්නේ definitely you can write something related to question number you can put question number and then I have said electronegativity depends on three factors you can write it sometimes you know that I know right then මම මේක දන්න ඕනේ මොකටද ලියන්නේ when you write something when even you know that the time that is protected in your mind stored in your mind will increase right? And then it is solidly deposited intensely deposited right really important so then electronegativity will depend on three factors hybridization charge and oxidation number right so then in hybridization we have three hybridizations then sp sp2 sp3 so then towards this way s percentage is increased higher the s character higher the hybridization right higher the s character higher the hybridization When you consider charge, we can say higher the positive charge, higher the electronegativity. Right? Higher the positive charge, higher the electronegativity. Then related to oxidation number also, higher the positive oxidation number, higher the electronegativity. So then for these species, you have to draw the shapes. SCl2. This will take like 1 minute. 1, 2, 3, 4, 5, 6. SO3 2 minus. SO3 2 minus. Sulfur. Around sulfur you have to keep 6 electrons. SO4 2 minus. SO4 2 minus. Then SO2. SO2. 1, 2, 3, 4, 5, 6. SO3. I think you can see it. I'm drawing it here. SO3. Now, what is the formula to get the hybridization? SPn minus 1. This formula එකක් නෙවෙයි. my classes වල මම ගන්න එකක්. SPn minus 1. N means sigma bonds plus lone pair. Add sigma bonds plus lone pairs and subtract 1. You will be getting the relevant hybridization. Right? SPn minus 1. Add sigma bonds and lone pairs and subtract 1. You will be getting the relevant hybridization. Is it clear? Right. What is the hybridization here? 1, 2, 3, 4. It is sp3. So S character is 25%. How we get the S character? S, P, P, P. You have 4 orbitals. The entire character is 100%. 100 divided by 4 is your S character. Right? So here also sp3. 1, 2, 3, 4. Here also sp3. Okay. But these two, 1, 2, 3, this is sp2. Okay. And then this is 1, 2, 3, it's sp2. So then the species with sp2 hybridization shows highest electronegativity. So now out of these two species, how to sort out which species is having highest electronegativity? See the next factor, right? What is the next factor? Charge. Charge of the central atom. We can see the charge of the central atom is 0. So then that factor is not available here. We can input කරන්න බෑද? එහෙනම් oxidation number එක බලන්න. Right? What is oxidation number? It is electron flow plus charge. Electron flow plus charge. Right? Electron flow එකට charge එක එකතු කරන්න. අන්න බලන්න. Right. So then here, what is the oxidation number of this sulfur? How many electrons were given out? How many electrons were given out? Right? 1 electron, the second electron, third electron, and fourth electron. Right? Then from this sulfur, since oxygen is more electronegative, it is releasing 4 electrons out. That is plus 4. Then here this sulfur, it is releasing 6 electrons. Right? The main sulfur electrons හතරක් යනවා plus 4. When it is losing electrons, the oxidation number is a positive value. Right? Then plus 4 plus 6. So you can clearly understand, higher the positive oxidation number, higher the electronegativity. So there, that's the reason for this two. Answer is answer number 4. And then this 3, we can see the oxidation number. Definitely the positive value of the oxidation number will increase. Let's see. Right? Now here, which one is more electronegative? Fluorine electronegative than sulfur. How we say like that? The multi electronegativity values ටික මතකයි. Fluorine 4.0, oxygen 3.5, fluorine nitrogen 3.0, carbon sulfur 2.5, phosphorus hydrogen 2.1. Those values you have to keep it in your mind. So then fluorine is more electronegative. So then we can say sulfur plus 2. This is 1, 2, 3, 4. All the 4 bonds we have to consider plus 4. Then this is plus 6. Right? Plus 2, plus 4, plus 6. Is it clear? That is the answer. First check with hybridization. Then arrange the species. If they have same hybridization, check the charge. If the charge is same, check the oxidation. Okay. So please raise your hands if it is clear. This is question number 11. Right. You can take a screenshot because if I'm giving the time to write this, it will reduce the time period to be the discussion, right? So you can take a screenshot and you can write a proper review for this. We'll be sending an MCQ review also with this. Okay. You can download it with the link. Next one. Question number 12. I think you have suggested question number 12. Yes. Answer is answer number 2. So this is case B. right? This is case B. It's very simple. Magnesium chloride is available and magnesium hydroxide is available. How we identify which species will dissociate partially and which species will dissociate completely, right? How to find that? How we identify which species will dissociate partially and which species will dissociate completely? Definitely, they are giving a Ksp value, or whether they are asking a Ksp value. Can you see? Solubility product of magnesium hydroxide. They are given a value. This species definitely dissociating partial. So for magnesium chloride, they haven't given any dissociation, right? For magnesium chloride, they haven't given any dissociation. I mean, any Ksp value. Magnesium chloride Ksp did an. So then because of that, we can understand that is completely dissociated. දැන් හුඟක් ළමයිට ඔය ප්‍රශ්නේ තියෙන ඉෂුව එක ඕකයි. Complete dissociation or partial dissociation. There's a small trick to find it. පොඩි trick එකක් තියෙනවා ඒක හොයන්න. ඒක තමයි මම කිව්වේ. හරි. If they are asking the Ksp value or if they have given the Ksp value, that species will partially dissociate. That's an equation. You have to write the Ksp expression for that species. So for magnesium chloride, you can see there, they haven't given any Ksp value or they are not asking any Ksp value. It's completely dissociated. That's a simple technique to find it. Otherwise, you should know S-law. Okay. Magnesium hydroxide is less soluble and magnesium chloride is well soluble in what? According to the solubility rules, right? Yes. So then here, I'm going to get the question answer. Magnesium hydroxide partially dissociate to give Mg2 plus aqueous plus 2OH minus. Maximum hydroxide concentration that can exist in 1.775. So this is C, initial concentration. The solubility, this is solubility, X, and here you get X, and this is 2X. So there, this is 2X. And then we have magnesium chloride, MgCl2. This will dissociate to Mg2 plus and 2Cl minus. Right. So here we have 1.775. This is completely dissociated to give 1.775 and 1.775 into 2. Clear? This is 1.775 and this is 1.775 into 2. Here I am completely dissociate can Ksp දීලත් නැහැ අහලා. අන්න point එක. හරි. මේ Ksp දීලා තියෙනවා. බලනකොට මෙහෙමද? එච්චර මහන්සි වෙන දෙයක් නැහැ. Right. Now we can see what is the common 9. මේ ඉන්නේ common 9. Then apply the Ksp expression. මුලින්ම කියන්න ඕනේ Ksp වලට බය වෙන්න. හරි. Ksp is equal to දැන් සමහර ළමයි මට ගොඩක් අය කියනවා physical අමාරුයි. Physical questions තව ටිකක් කරන්න ඕනේ. ඒක තමයි resource book එකේ questions ටික කරන්න පටන් ගන්න. මමත් මේ 21 paper එක discuss කළා resource book එකේ questions ටික physical questions ටික හොඳම ටික ආයෙ discuss කරනවා class එකේ. right හොඳම ඒ සාරාම questions තියෙනවා. ඔයගොල්ලෝ පටන් ගන්න kinetics වලින්. resource book එකේ උත්තර හදලා නැති answers තියෙනවා. අන්නේ questions ටික ආයෙ කරන්න ගන්න. question එක ලියනවා answer එක ගන්න. question එක ලියනවා answer එක ගන්න. බලන්නේ නැති. ඒ program එකක් යන්න මේකත් එක්ක කරන්න. resource book එකේ questions. නියමයට පුළුවන්. හොඳම හොඳ questions ටිකක් තියෙනවා. හරි ඒවා ටිකයි past papers term test papers කරාම තව මොනවා? This is hydroxide. OH minus AK squared. Then we can apply magnesium. This is 1.775 plus X. And magnesium ටික හරි. hydroxide ටික කීයද පුතා? මේකේ. හරි. hydroxide ටික ඇවිල්ලා 2X වල squared. අපෙන් question එක අහන්නේ මොකක්ද? So then they are asking maximum hydroxide concentration. No need to get 2X. Just get it as hydroxide. Right? 2X කියලා ගන්න ඕනේ. Take it as hydroxide. OH minus aqueous square. Ksp value they have given 7.1 into 10 to the power minus 12. Right? So then you have to do an important assumption. You know this, when we consider a partially dissociated species with a completely dissociated species, when we add the two concentrations, there's an assumption 1.775 plus X is approximately equal to 1.775. Clear? When you consider a completely dissociated species with a partial dissociated species, we can consider the partial dissociated concentration is negligible compared to the initial one. In a multiplication, we can't consider like that. In a division, we can't consider like that. But in addition, in a subtraction, we can take like this. Just think 100,000. 100,000 plus 2. I can say it is approximately equal to 100,000. 100,000 minus 2. I can approximately say it is equal to 100,000. In addition and subtraction, we can do this assumption. Can we say 100,000 into 2? Approximately equal to 100,000. No. In a multiplication, it is impossible. 100,000 divided by 2. It's approximately equal to 100,000. We can't say like that. Right? So then here, I can solve it nicely. 7.1 into 10 to the power minus 12. When you add these two, you have to neglect the amount x here. 1.775 into OH minus into square. Right? OH minus into square. So then 1.775 is 1. 7.1 is 4. So you can easily we can take that OH minus aqueous squared is equal to 4 into 10 to the power minus 12. Then we can take the OH minus amount is the square root of this. This is 2 into 10 to the power minus 6. Right. Then I have directly found the value of OH minus. So then question number 12, the answer is answer number 2. So please raise your hands if it is clear. Answer is answer number 2. Right. So definitely, when you are doing these questions, you should do these rough works. If you couldn't do the rough works like that, in your review, you have to do like this. Right. You listen to capen dila tiyenne me. Samahara ay dannet naha. 1.775 over 7.1 වලට හරියටම 14. Right, okay. Very good. Let's move to the next question. Please take a screenshot. Or with me, if you have done the question, that's great. Right? මම question එක කරනකොට මගෙත් එක්කම කරගෙන ගියා නම් හරි. The review එක ලියන්න වෙනම time එකක් යන්නේ නැහැ. අත ඔයගොල්ලෝ හිතන් ඉන්නේ මේකට review එකක් ලියන්න ඕනේ කියලා හිතන් ඉන්නව ලියන්න බෑ. සමහරට තියෙන paper එක කරන්න වෙන්නේ නැහැ. වැඩ ගොඩ ගහයි. නේ? So try to manage your time. Next. You have asked question number 14, right? There are two answers, 2 and 5. Okay. Correct statement they are asking. Please read the question well. Bond angle of NF3 is larger than bond angle of ammonia. Right. Bond angle of NF3 is larger than bond angle of ammonia. So that is incorrect. Why it is incorrect? Again, I will explain කරන්න. So when we consider NF3 and NH3, which is the same, right? There are some questions like this. NF3 NH3 NH3, right? Now here we know fluorine is more electronegative, so then these electrons are very close towards fluorine. You know, in NF bond there are electrons. Generally the electrons are available at the same time, but since fluorine is more electronegative, these electrons are very close to fluorine. Here the opposite version of that. The electrons are very close to nitrogen. Right? So you know this lone pair is repelling this. Right? This lone pair is repelling this bond. So in which one you get the greatest repulsion? In which one you get the greatest repulsion, highest repulsion? Okay. Is it first one or second one? Just imagine. You will have the highest repulsion. I mean, the lone pair here will successfully repel the bond. Push the bond in which case? Is it 1 or 2, as you believe? In 2, it's impossible because this lone pair is also trying to give effect to this. Because the lone pairs are closer to each other. So when one lone pair is trying to hit the other, this lone pair is trying to hit this. They will fight together. So that will not reduce the bond angle much more. But here, you can understand the value of the bond angle is reduced to a great extent as there's no lone pair available here. Then this one will attack successfully to this, right? And then the bond angle will be reduced. So then when you consider NF3, in NF3, the bond angle is lower compared to NH3. NH3. Isn't it? That's the reason. So you can explain it using the repulsion between lone pair and bond pairs. You can say lone pair bond pair repulsion is highest here. Or in another words, you can explain in bond pair repulsion. Now here bond pair repulsion is high. Bond pair repulsion is high. That's what the bond angle is increased. Here bond pair repulsion is low. Like so, then you can use either the bond pair repulsion or bond pair lone pair repulsion. So then the first statement they are saying the bond angle of NF3 is larger. That is incorrect. Right? But the definite statement again. Elements in group 17 exhibit oxidation states from -1 to +7. Elements in group 7. In the exam, we have considered that answer as true and false. So actually, elements in group 17 exhibit oxidation states from -1 to +7. Because fluorine doesn't exhibit oxidation numbers from -1 to +7. What are the oxidation numbers of fluorine? Can you tell me? What are the oxidation numbers of fluorine? Fluorine, what are the oxidation numbers? There's only 2 oxidation states available for fluorine. For fluorine, there's only 2 oxidation states. Very good. That's -1 and 0. Fluorine doesn't show positive oxidation states. Okay. It's really important. Fluorine doesn't show positive oxidation states. If you get fluorine, how many oxidation states available for fluorine? Okay. Bromine and iodine. These three species will have oxidation states starting from -1 to what? I mean, all the odd numbers are available, not even numbers, right? -1, 0, +1, +3, +5, +7. So these species are having these oxidation numbers, but because of fluorine, we can take this statement as incorrect. Or they haven't given all elements. Even all elements so because of that, you can consider this statement as true also. Right? However, they have given 2 answers. Right? Answer number 3. Monoclinic sulfur is the most stable allotropic of sulfur at room temperature. You know, related to sulfur, it exists as S8. The most stable form of sulfur is rhombic sulfur. Okay. Not monoclinic sulfur, should be rhombic sulfur. Then 4th one, the density of graphite is higher than the density of diamond. Okay. I want to connect the term. Density of graphite and diamond. Diamond is higher than graphite. It's a clear answer. That one, monoclinic sulfur is the most stable allotropic sulfur. Yeah, it's incorrect. Question number 4. Right. Question number 4 again. Correct again. The density of graphite is higher than that of density of diamond. It's also incorrect, right? Density means the amount of mass. So when you consider the density of diamond, it is higher than the graphite. So for question number 14, they have given answers. The 4th one is also incorrect. The 5th one, right? Aluminium chloride satisfies the octet rule in the gaseous state. That's true. In new syllabus, aluminium chloride undergoes dimerization. Aluminium chloride undergoes dimerization in the gaseous phase in order to satisfy the octet. This is book gaseous phase, it will form Al2Cl6. So you can draw the reactive bonds here. There are 2 reactive bonds. Not only aluminium chloride, but also BCl3, BF3, BeH2, BeCl2. Those species will also undergo dimerization in order to achieve the octet. Right. in order to achieve octets. Then answer is answer number 5, answer number 2, right? As a general statement, statement number 2 is also correct. So the answer එකට මේ marks මේ answers දෙකම දීලා තියන්න ඕන දෙකෙන් එකක් තිබ්බම marks හම්බෙනවා. Next one, we have discussed question number 14 as your request. Question number 15, 16, 17, 18, 19. Okay, ඔක්කොම ටික තියෙනවා. 15 මේ මොනවද discuss කරන්න දෙයක්වත් නැහැ. Very simple. Now here the standard reduction potential of this one. Can you see here they have given Mn2 Mn2 plus. So then as it is an oxidation, we can understand this is anode, right? This is Br minus to Br2. මේ තියෙන reduction එකක් -1 to 0. So this is cathode, right? So then they have given the electromotive force of the cell. The cell එකේ potential එක තමයි මේ දීලා තියෙන්නේ. So you can mention that E0 cell is equal to E0 cathode minus E0 anode. And the cell කියලා කියන්නේ 2.27, right? 2.27. So what is E0 cathode? Cathode can be BR2, right? They have given that value, so then take it 1.09. So E0 anode within anode එක තමයි අහන්නේ. Standard reduction potential of Mn2 plus to Mn. That's what they ask. You just subject it, and then you will be getting the answer. E0 A, E0 anode is equal to 1.09 minus 2.27. Right? So for question number 15, the answer is answer number 2. Very simple, right? Now, simple questions we will discuss කරන්න. Very good place in it. Then question number 16, right? මෙහෙම එකක් අහලා තියෙනවා question number 16 එකේ. The enthalpy of vaporization and the entropy of the vaporization of liquid are, they have given some values, and they are asking the boiling point of the liquid. So what is the equation you have to apply? So there is enthalpy, entropy, and Gibbs free energy. Enthalpy, entropy, and Gibbs free energy. So what is the relevant equation that we are applying? That is delta G equal to, what is the equation again? Delta G equal to delta H minus T delta S. If it is at standard conditions, we can put delta G naught, delta H naught, and delta S naught, right? Okay, so then enthalpy change of variation on enthalpy change of vaporization and the entropy of vaporization of liquid are, right? So then you should understand this vaporization process. Okay, we know a liquid to a gas. This vaporization process, yeah, definitely it's an equilibrium reaction. A vaporization is equilibrium reaction. So here delta G value is 0, right? So then delta H you can apply. We have given it in kilojoules per mole. This is 45 kilojoules per mole. Temperature they are asking, so we will be getting the temperature in kelvins. And especially when we are applying delta S here, they have given delta S in joules Kelvin per mole. Don't apply it. When you apply it to here, you have to apply it in the standard units, which is kilojoules Kelvin per mole. Then delta S apply karanna mole kilojoules Kelvin per mole, right? So then here, this is 90 into 10 to the power minus 3 kilojoules Kelvin per mole, right? Then you can just put the sides there and there. So you will be getting 90 into 10 to the power minus 3 into T is equal to 45, right? Then 45 is 1, 90 is 2, right? Then you can take the answer from here. The temperature you can obtain 10 to the minus 3. Then it's 1000 over to like 500 Kelvin. But 500 Kelvin is not available in the answer, so then you have to convert it into Celsius. You just subtract 273 from this. Then you will be getting 227 Celsius. That's the answer. It is answer number 5. Question number 16. The answer is answer number 5. There. Right. Question number 17. So please read question number 17. Question number 15 එක ගැන මම question එකක් අහලා තියෙනවා. Question 15 එකේ reduction එක අහලා තියෙනවා. ඔව් එතකොට 1.18 එකේ sign එක මාරු වෙන්නේ නැද්ද? මේක explain කරන්න. හරි? හොඳයි. මම කියන්නම්. මම කියන්න හිටියේ ඇත්තටම. හරි. දැන් මෙහෙමයි. the standard reduction potential of Br2 make a sign එක මාරු කරන්න නැද්ද කියලා තමයි අහන්නේ. The standard reduction potential of this. Okay. So then there's a misunderstanding in this question we have. First of all, you should know E naught cell is equal to E naught cathode minus E naught anode. I'm going to now we know anode is undergoing oxidation, cathode is undergoing reduction. That's clear. But for this equation, that is not required. This equation is entirely made considering the reduction potentials. This E naught cell is expressed in terms of reduction potentials. We are writing electrochemical series by increasing the reduction potentials. By increasing the reduction potentials, even for sodium, we get reduction potential. Even for calcium, we get reduction potential. Even for iron, we get reduction potentials. So this equation is entirely made out of reduction potentials for all the species, including anode, including cathode, including cell. That's the reason. So for cathode, you have to apply reduction potential. So for anode, you have to apply reduction potential, or you have to find reduction potential. And E naught cell is also a kind of reduction potential. Right? I mean, it is a difference between reduction potential. That's what, right? In the electrochemical series, we have reduction potentials. We are getting the gap. The gap should be a positive value. Always you have to subtract cathode from anode for that positive value. Then for the cathode and anode, you have to get, or you have to apply reduction potentials only. So then after getting the reduction potential, if you invert the sign and make the value to the next version, I mean, if it is minus 1.18, if you are getting it as plus 1.18, you have missed the concept. Because even for anode, we have to find the reduction potential of the anode. Right? So from the equation also, you get the reduction potential. No need to convert it, just keep it. Okay. When you do more questions related to this, you will experience the situation, right? Don't change any sign. Question 17. Incorrect statement related to this. Actually, what is this? C6H5 N2Cl. Plus charge. This is called benzene disonium chloride, right? So there are some reactions, organic reactions. So for question number 17, they have given answer as answer number 4. To see whether you have taken answer number 4 correctly, or if you have missed it, what is the issue, right? I'm going to discuss. Okay. Right. So question number 17, it is benzene, and then this N triple bond N, here there's a positive charge, and then here there's lone pairs, and this is Cl minus. This is the correct format of the disonium chloride. This is stable only at low temperatures, right? Can be obtained by reacting NaNO to HCl at 0 to 5 Celsius. Aniline, yes, that's true. Okay. So then the first statement is true. When you react aniline NH2 at NaNO2 with NaNO2 dilute HCl at 0 to 5 Celsius, you get disonium salt. If you increase the temperature, you get phenol. Right? If you increase the temperature, just like 10 Celsius, for the same reaction, you get phenol. Statement 1 is correct. Statement 2 reacts with Ki to give iodobenzene. That's true, right? You can add potassium iodide, you get iodobenzene. Right? Potassium iodide, you get iodobenzene. So that is question number 17. This is answer number. Right. So 3, disonium ion can act as an electrophile. That is true. Because when this disonium chloride reacts with phenol, disonium chloride reacts with phenol, do you know what will happen? One of these chlorines will be removed with hydrogen ski. In phenol, it's an ortho-para reagent. So from ortho place, or otherwise the para place, we have to remove hydrogens when it is reacting with diisonium chloride. So then what will happen? This chlorine will be removed with one of the hydrogens in these places. One of the hydrogens in these places. So easily we will get this as OH. So then where we have hydrogen? Okay. Here we have hydrogen, here we have hydrogen, and here we have hydrogen. This hydrogen will be removed with this chlorine. This hydrogen will be removed with this chlorine. So then this disonium ion will be added to benzene, like NO2 plus, CH3 plus, CH3CH2 plus, CH3CO plus. Okay. Now for benzene, electrophilic substitution reactions are possible. So then disonium ion is substituted instead of hydrogen. So you know this is hydrogen. This hydrogen is removed with this chlorine. The disonium ion is substituted here, getting the azodine, giving the azodine like this. Right? Azodine formation is an electrophilic substitution reaction. Disonium ion is the electrophile. Within disonium ion, electrophile. Azodine formation. Okay. Red orange color dice you will be getting. Then is a hari prashnak mein. Question number 3. Make incorrect answer. Answer number 4 kila mahi tane dila tene. When aqueous solution of disonium salt is heated, it decomposes to give benzene. Nah. Disonium salt will benzene in heat kara. Right? When you heat disonium chloride, what you get? You know. Now NaNO to DiHCl, when you keep it in ice, you get disonium chloride. Right? But if you have heated, you are increasing the temperature. So if you are increasing the temperature, definitely it will give phenol. Disonium chloride is heated to give phenol. If you want to get benzene, you have to add H3PO2, right? We have to add H3PO2 hypophosphorus acid in order to get benzene. That's the reaction. Okay, answer number 4 එක වැරදිනේ. අපි benzene chart එක බලුවා නම් හරි. So then reacts with phenols in basic medium to give colored compounds. Disonium chloride reacts with with phenols in the basic medium to give colored compounds. Yes, this one, right? Make a sodium hydroxide medium. So then here, if it is happening in the sodium hydroxide medium, should be sodium phenate. Right? I mean, should be sodium phenate. Azodine formation is taken in the sodium hydroxide of the basic medium. Right? Incorrect statement they are asking. Question 17, answer is 4. Yes, raise your hands if it's clear. Any issues? Right, thank you very much. Yeah. Next one, it's question number 18. Question number 18. H2S reacts with O2 to give only H2O and SO2 as products when 4 cubic deciliters of H2S reacts with 10 cubic deciliters of O2 at constant pressure and temperature. Final volume. This is type of PV coordinate equation. You can see here they are given constant pressure and temperature. So then when pressure and temperature is constant, you know R is constant, volume is proportional to number of moles. Athara me dila thiyene number of moles. Right? Me dila thiyene number of moles. Volume is proportional to number of moles. Clear? So then here in this question, H2S reacts with O2 to give H2O and SO2. Balance reaction, okay? First of all, write the reaction and balance it. Make a balance karagan. H2S reacts with O2 to give H2O and SO2. H2S with O2 to give SO2 and what? Okay. See how I'm balancing this? I need your support. Now, use the inspection method to balance this. You can see here there's one sulfur, here there's one sulfur. Sulfur is balanced. Sulfur is balanced. right? Here there's two hydrogens. Here there's two hydrogens. Hydrogen is balanced. So which one is imbalanced? Which one is imbalanced? Only oxygen. So I have taken this term, I've taken this term, and I have taken this term. So when I'm balancing oxygen, I have to take the next term and balance it. What is the figure we have to place? Would be a decimal value or a fraction value, no issue. What would be the value we have to put it here in order to balance it? Can you predict it? Send your answers. That's how to process inspection method, right? Getting least atoms first and then try to balance it with the rest. Yes. So then here 2 plus 1, that's 3 oxygens. There's 3 oxygens available here. So then what we have to do? What we have to do? So that when there's 3 oxygens available, if you put 3 here, what will happen? Then it will become 6, isn't it? Then the 3 place karot 6 venama, because 3 is multiplied with this 2. So in order to avoid the multiplication, we can do something. In order to avoid the multiplication, you can divide this one by 2. Because 3 over 2 into 2 means 3. 3 over 2 into 2 means 3. Right? It's 1.5. So now this equation is balanced. If you don't like the fractional values, you can just remove it by multiplying from the denominator, all the terms. So then I'm removing this. Right? So let's remove if you want. Right? So in this 2, this is 2. Right? So we are multiplying from 2, this is cancelled. Here it's 2, here it's 2. Equation is well balanced. Right? That's how we start. Right? Okay, next we can write the initial moles, reacted moles, final moles. Set up. Right? Stoichiometric numbers are proportional to the reacted moles and produced moles. The stoichiometric numbers are proportional to the reacted moles and the produced moles. Clear? Right. So here, initial, reacted, and final. Initial, reacted, and final. What is initial? When 4 cubic decimeters of H2S. Here we have 4 cubic decimeters. 10 cubic decimeters of water. Okay. That is enough. What is the limiting factor? As we guess, from where we have to start, just forget the cubic decimeter thing. Number of moles is proportional to volume. Just think this is number of moles. Think this is the number of moles. Right? 4 moles, 10 moles. Yes. Now, limiting factor. The species with the lowest number of moles. So then the species with the lowest volume, I'm taking this one as the limiting factor. I'm taking entire 4 is reacting. So then the final amount should be 0. If this is the limiting factor, right? Sometimes it could be, sometimes it can't be, right? I mean, there's a probability. Okay. Now, what is the reacted amount of O2? I'm going to confirm whether this is the limiting factor. Just forget this. Right. Now, what should be the reacted amount of O2? Oxygen kochara react when only. Use the column method. H2S O2. 2 to 3. With 2 moles of H2S, 3 moles of O2 is reacting. Then with 4 moles of H2S, right? 4 moles, 4 cubic decimeters, 4 moles. With 4 moles of H2S, what should be the reacted amount of oxygen? Yes, oxygen kochara on the react when? 2 එක 3 on. And 4 එක කියක් ඕනද? Just multiply 2 times crosswords and divide from the remaining. That's the value. 4 into 3, 12. 4 into 3, 12. 12 divided by 2. 4 into 3 is 12. 12 divided by 2, what is the value? It is 6. Right? 4 into 3 is 12. 12 divided by 2 is 6. So then we need 6 cubic decimeters of O2 to react. So then just see whether it's available. Yes, we have that. Yes, we have more than that. Right? Then we have 10. Just react 6 from that. 6 from that. So then what is remaining? 4 cubic decimeters will remain. Right? So this is confirmed as the limiting factor because the other species is reacting with that successfully with the ratio. Okay, what is the produced amount of SO2? Okay, now we know when 2 moles of H2S reacts, 2 moles of SO2 is produced. When 4 moles of H2S react, here we get 4 moles or either 4 cubic decimeters. 2 is producing 2. So here also, when 4 is reacting, this is giving 4. Then they are asking the volume of the gaseous mixture, final gaseous mixture. So you can add this together. 4 plus 4 plus 4. The answer is answer number 4. Is it clear? Please raise your hands if it's clear to you. Right, you can write something about that. Okay. The balancing method and then this. There is question number 18 I have discussed. Next one is question number 19. That's the difficult question. Right? It's a kind of a difficult question. We'll discuss. This question number 18. Yes. Next one. Question number 19. Right. A mixture of A gas and D gas was infused into a rigid evaporated container at temperature T. At this temperature, both A gas and D gas decomposes according to the elementary reactions given below. So then they have given 2 reactions, right? The initial pressure of container P, initial pressure P means the pressure of A and D. It was P. Okay. Change to 2.7 P. Change to 2.7 P, that means total pressure after the decomposition of both reactants. Okay. Complete decomposition kela dila denawa. Right. Initial rate of decomposition of A gas, at this temperature. Okay. R is the universal gas constant. So then it is a question type to be skipped in the first attempt, right? Again, I'm going to පළවෙනි පාඩම මේක කරගෙන යද්දී ඒ question එකක් skip කරා නම් හොඳයි කියලා මට හිතෙනවා. මොකද ටිකක් වෙලා යනවා question එකේ answer එක ගන්න සමහර ස්ටුඩන්ට්ස්ලා ඒක try කරද්දී, right? Okay. So we're going to write the reactions of that and discuss the answer. Let's see. This is the discussion of question number 9. To A gas is converted to B gas plus 3C gas. D gas is converted to B gas plus 2C gas. A mixture of A and D was introduced to a rigid evaporated container at temperature T. Both A and D decompose according to the elementary reactions given below. The initial pressure of the container P has changed to 2.7. Right. So initial pressure you get from P here, that is changed to 2.7 P. Okay. Initial rate of decomposition. So actually initial rate will depend on the initial pressure. Initial rate will decompose, change to the initial pressure. Okay, we can take like this. So actually we want to write the rate for this reaction, right? Initial rate of the decomposition of A gas. So we'll start from that. If you are writing the initial rate of this A, it's an elementary reaction. Just write an expression, rate equal to K times concentration of A gas into power of 2. Rate equal to K times concentration of A gas into power of 2. Right? I mean, the stoichiometric coefficient is 2 here. As the stoichiometric coefficient is 2 here, the initial expression, rate expression is here. Then here what we need initial pressure. Right? So for this, we need initial pressure. And we can take the initial pressure as P dash. We know the total initial pressure is P. Total initial pressure is P, so then we can take this one as P dash. Because we have to apply it to here. R equal to K times P dash into square. We have to find an expression for P dash in terms of these given ones. So actually in terms of P. So what we can do, right? So then they have given the total final pressure as 2.7. And then this, so just think we are applying PV equal to nRT for this A. Then the P is P dash. Okay, able to whether PV equal to nRT apply karot. Then this A, we can consider it as the partial pressure of A. The partial pressure of A into V into the number of mass of A, right, into RT. Right. Number of mass of A into RT. So from there, we can derive an expression for the concentration of A. I mean, this is concentration, right? So we know P is equal to CRT. From PV equal to nRT, we can derive the expression P equal to CRT. So you know concentration is equal to P over RT. Right? Concentration is equal to P over RT. So then here also the concentration of A, you can take the concentration of A means the partial pressure of A, which is P dash. The partial pressure of A, P dash over R into T. Right? Concentration of A means the partial pressure of A, the partial pressure over RT, P dash over RT. Isn't it? P dash over RT. That's very important. So, P dash over RT can apply it to here. R equal to K times, instead of concentration of A, you can apply P dash over RT square. P dash over RT square. Right. So let's get an expression for P dash. Can you understand? Initially, I have directly applied P dash for A, but it is impossible because A is concentration of A, P dash is partial pressure. So we have to get the relationship between that, P equal to CR. So this is P dash, and then this is concentration of A. From that we can get an expression. Concentration of A is equal to P dash over RT, and we will be getting it like this. When this is P dash, what is the value of D? What is the pressure of D? That is P minus P dash. Right? When the total pressure is P, and when this part is P dash, it should be P minus P dash. They're telling this is completely dissociated. Completely dissociated. So then if P dash is completely dissociated here, what is the product? This dissociated amount is proportional to the stoichiometric coefficient. So with respect to 2, if P dash is reacting, with respect to 1, what is the produced amount? That is P dash over half, which is 0.5 P dash. Isn't it? 0.5 P dash. 0.5 P dash. Clear? Okay. Then from here 2, we get 3 here. 2 is to 3. 2 is to 3. That means, actually, we know P dash is proportional to 2. That means 1 is proportional to P dash over 2. Here it is producing 3. A, C. 2 is producing 3. So when there's P dash, what is the produced amount? That is 3P dash over 2. Isn't 3P dash over 2. Then this is not available because it's completely reactive. Okay. So from here, what is producing? This is completely reacting. This will produce again P minus P dash because 1 is producing 1. Here 1 is producing 2. This should be 2 into P minus P dash. Okay. Then what do you have to do? You have to add all the pressures. This, with this. Add all these 4, then you can equalize it into 2.7. You can add these 4 pressures and equalize to 2.7. So we can say 2.7P. 2.7P is equal to what? This plus this plus this one plus this, right? 0.5 P dash plus 1.5 P dash plus P minus P dash plus, solve the bracket, 2P minus 2P dash, right? 2P minus 2P dash. So when you solve it, you'll be getting the answer for P, 2.7P, 0.5 P dash, and P dash, and then this is 2P dash. Simplify this, then you will be getting the answer. P dash is equal to 0.3P. 0.3. P dash is equal to 0.3. That means we can apply it to here, right? We're going to find the rate equation. So we can apply it to here. That is rate equal to K times, instead of P dash, you can write 0.3P over RT. RT into square. Clear? So in the answer, they have taken 0.03 squared out of the bracket. 0.03 squared out of the bracket. So we know 0.03 means, 0.3 squared means 0.09. 0.09. Take it out of the bracket, right? So R equal to K times 0.09 P of RT squared. Right? P of RT squared. Let's understand what we have done. We have written an expression, we have considered the partial pressure of A as P dash. Considering the partial pressure of A as P dash, we have written the expression for the dissociation. And then we have taken the pressures of the other species. Addition of those pressures is equal to the final pressure 2.7. Okay, 2.7. Okay, so then take your answers. Is it clear to you? You see it? You can write something. Start from here. Just read the question. Just read the question also. Right, okay. Come on to the next question. Okay, so then I have discussed question number up to 19. I think for the question number 19, the correct answer is answer number 3 here, right? Question number 20, we don't want to discuss, right? Okay, so then starting from next part, the product 21 to 30 take a discuss කරන්න ඕනේ නේ. 21 to 30 is send the questions. 21 to 30. You can just get it from here and you can put your marks out of 10. 21 to 30 out of 10. Right. I'm going to discuss. Right. Right. Go back. 24. Right. 21. 22. Right. 21, 22, 25. 24, 27, 29. Right. Another 30. ඉතුරු questions දෙකත් බලලා යන්න බෑ දැන් ඔලේ. තව ගයිඩ් එකක් දෙන්න. හරි. Okay. මම එහෙම කරන්නේ structured වෙලාව ගන්න කියන තමයි මම discuss කරනවා. Right. 21, 22. Main answers. Right. 21 අතරම difficult. ආන්න දෙයක් නෑ. 22. ඔයගොල්ලෝ දන්නවද මේ 21 question එකම තමයි. ඔය 21 කියන MCQ එකම තමයි. After some improvements. Right? After some improvements, the 21th MCQ is made to an essay question. Right. You know, 2019 A-level paper is starting with a PH question. Starting with a PH question, this is just a 21 MCQ, 21st MCQ. MCQ become may have clear. Keep remember that thing. Can එකම කෙනා තමයි මේ questions දෙකම හදලා තියෙන්නේ. MCQ එකයි මේ question එක. Right. Yes. So these MCQs are really important. 21, 22. I'll discuss 22 first, right? 22 එක මොනින් කතා කරන්නේ. Consider the following 3 aqueous solutions. So then for 22, the answer is answer number 2. When each of the solution is diluted by same amount at constant temperature, diluted means adding water, right? The pH of PQ are respectively. pH of PQ are respectively. So then we know P is a weak acid, like CH3COOH, right? Q is equimolar mixture of weak acid and sodium salt, CH3COOH and CH3COONA. our titration mixed at equivalence point of the titration of the weak acid and a strong base, right? Weak acid and a strong base, a pH question. So we know weak acid, we can get weak acid like acetic, CH3COOH, strong base like sodium hydroxide. So at the equivalence point, what we have? At the equivalence point of this titration, equivalence point means they are reacting in 1-to-1 ratio, right? Then this OH minus will react with this H plus and it is converted into water. And then here we get CH3COONA. Right? CH3COONA. This acidic with sodium acetate, and this is sodium acetate. So here, when we get this condition, acidic with sodium acetate, and here we have sodium acetate, PQ1. So then dilution means adding water. Then how the pH will affect, right? You know the equation, pH is equal to pKa plus log 10. pH is equal to pKa plus log 10 salt or acid, right? Salt or acid, this is salt, CH3COON, right? Or acid, it is CH3COOH. So we have the acid and salt both. Acid එකක් තියෙනවා, salt එකක් තියෙනවා. Acid and salt both. So when we dilute, what will happen? The concentration is getting decreased. Dilution means increasing the volume. Concentration is getting decreased. So you can just keep it to here. When concentration of acidic is getting decreased, what would happen? Right? And the concentration අඩු වෙනකොට මොකද වෙන්නේ කියලා තේරෙනවද? So for question number 22, the answer is answer number 2. It is increased. You can see, according to the Henderson's equation, can we apply Henderson's equation to a weak acid? It is possible. Because weak acid is dissociated to the salt plus salt and its acid, right? I mean, CH3COOH dissociated to CH3COO minus and H plus. CH3COO minus means salt. Then, you know, weak acid is not completely dissociated. There's a remaining amount of weak acid, that is the acid. So Henderson equation can be applied to buffer solutions as well as weak acids or salts. You just get an idea about them. Right? So then I am explaining, when you decrease the concentration of the weak acid, the pH is getting increased. So then the first one, for the first part, it is increased. Okay? Increases. That's the case. Right? Then next one, an equimolar mixture of weak acid and its sodium salt. Equimolar mixture of weak acid and sodium salt, you know, when they have equal moles, when we are diluting, what will happen? They will reduce the concentration from same amounts. As we reduce the concentration of this one and this one from same amounts, the pH is unchanged, right? pH will not be changed. So then the second one, it is not changed. Not changed, right? Then the third one, okay, it's decreasing. How it is decreasing, right? So you know at equivalence point you have sodium acetate. Sodium acetate is completely dissociated to CH3COO minus and Na plus. So if you have decreased this concentration, acetate concentration will decrease. When you decrease the acetate concentration, pH value will decrease. Okay, pH value will decrease. So is it clear? The answer for question number 22 is answer number 2. Answer number 2. So please raise your hands if it is clear to you. This is a buffer solution, right? When we have the weak acid and when it reacts with the strong base, we get the salt. So salt plus weak acid is a buffer solution, right? Okay, can move to the next part. Question number 22. The answer is answer number 2. Increase, not change, decrease. Right. Question number, we have suggested the next question. 24 and 25 we have discussed. 24, it's also very simple. The density of an aqueous solution, they have given a certain density. If the pH of this solution is 1, the H plus concentration in pp. That's your answer, right? On the question of chemical calculations, answer is answer number 3. Have you got the answer? Have you get the answer here? Question 24. The density of an aqueous solution, right? So when you get the density, right? When you get the density, we know in 1 cubic decimeter, question number 24, in 1 cubic decimeter, they have given it's 1000 grams. Okay? Density means total mass. Mass of H plus, mass of water, and mass of impurities. Okay, in 1 cubic decimeter, the mass is 1000 grams. Okay. Total mass. So then they have given the pH of this solution is 1. So we know when the pH is 1, the H plus concentration is the pH 1 when H plus concentration 0.1 moles per cubic decimeter. Right? That means in 1 cubic decimeter, how many H plus moles we have? H plus moles or hydrogen moles, it is 0.1 moles. That means in 1 cubic decimeter, what is the mass of hydrogen? The moles is 0.1. How to get the mass? For W equal to Nm, number of moles you have multiplied by molar mass. When the number of moles is 0.1, the molar mass of hydrogen is 1. Molar mass of hydrogen is 1 grams per mole. So the molar mass of hydrogen 2 again, H2, and then H1. So H plus නෙදී. H plus කියන්නේ hydrogen වලින් electron එකක් අයින් වෙලානේ. Then the removal of electron is negligible. The mass of an electron is negligible. So then we don't mind it. We just get the mass of hydrogen atom. Right? So then this is 0.1 gram. Right? So here we have 0.1 gram. Here we have 1000 grams. That means in 1 cubic decimeter, the total mass is 1000 grams. In 1 cubic decimeter, the mass of hydrogen is 0.1 gram. There, mass of hydrogen is 0.1 gram. What do you have to do? You should get the ppm mass, right? How to get the ppm mass? How to take the ppm mass? This is how. When you get the ppm, that means the amount available in 10 to the power 6, right? The amount available in 10 to the power 6. So here we have to get the total mass, and here we have to get the mass of hydrogen, right? This is total mass, and then here we have to get mass of hydrogen, right? So when the total mass is, you can see when the total mass is 1000 grams. When the total mass is 1000 grams, the mass of hydrogen is 0.1 grams. When the total mass is 1000 grams, the mass of hydrogen is 0.1 grams. So the 1000 minus 0.1 t. In 10 to the power 6, you can see the available amount. Is it there? So then how we get the total mass? From the density. So from the density, we can identify there is 1000 grams. In 1000 grams, if we have 0.1, in 10 to the power 6, what is the available amount? The answer is answer number 3, it's 100. Please raise your hands if it is clear. This is question 24. Right? Yes, is it there? Right, okay. Question number 24. Write a review for that, right? Okay. Next one. 25. Okay. Next one is 25. 25 answer is 1. How we get this answer? Okay, that's also a calculation. මේක තමයි මේ වෙනකන් redox අහලා තියෙන එකේ මම දැකලා තියෙන විදිහට redox balancing එක අමාරුම question. හරි. يعني මේක redox balancing වල පොඩි trick එකක් තියෙනවා. පොඩි scene එකක්. Redox balancing. Right? Okay, let's see. 25 grams of sample of polluted air containing ozone is treated with an acidic solution containing excess Ki. Ozone is converted to O2 and water. During this reaction, the iodine liberated is titrated with thiosulfate. The volume of thiosulfate plus 25. The mass percentage of O3 in the sample is. Actually, the simplification part is simple, but the thing is balancing. Right? The balance කරගන්න එක තමයි පොඩි ප්‍රශ්නයක් case එකක් තියෙන්නේ. We'll see that. Question number 25. You can see 25 grams of sample polluted air containing ozone. So we have ozone. This is polluted air. Is treated with an acidic solution containing excess K. Right. So you are treating with an acidic solution, and then excess Ki is added. Ki means I minus. So then ozone is converted to O2 and water during this reaction. It is very specific. Generally, they don't give water is produced. In a redox reaction, we balance the redox reaction using water. Then they don't want to give water is produced. But here specifically they have given O3 is converted to O2 and water. So then it's very important to write the reaction. O3 is converted to O2 and water. Here the specific thing is the number of atoms. Here we have 3 atoms, but when you balance this, you don't want to put here 3 or here 3 because the addition of these oxygens is 3. You understand? 2 plus 1 is 3. So here we have 2 oxygens and here we have 1 oxygen. That is 3. And here also 3. Is it there? And then at that time, actually, I minus is converted to I2. I minus is converted to I2. Right. So then how to balance? Then balance iodine. Okay. And then that iodine making I2 liberate making I2 liberate. So actually that liberated I2 is reacting with thiosulfate. That liberated I2 is reacting with thiosulfate. Okay. S2O3 2 minus. So in this thiosulfate, concentration is 0.002. The volume is 25 cubic centimeters. So what is the reaction between I2 and thiosulfate? Very simple, right? So then you know I2 reacts with S2O3 2 minus. S2O3 2 minus is converted into S4O6 2 minus. I2 is reduced into I minus. Right? I2 is reduced into I minus. So we can take here 2 and here 4 and here 2. Like this. Okay. First of all, we have to balance the previous equation. Now see how to balance the previous equation. This is the way. So then here we have 2 iodines. Here we can put 2 and make it 2. So here 0 and here minus 2. The difference is 2 here. Right? But when you balance it here, especially here 3 oxygens and here also we have 3 oxygens. This is a combined species. Oxidation number of ozone is 0. Oxidation number of ozone is 0. Entire species, as it's a standard species. And then the oxidation number of O2 is also 0. You know, so then that is not undergoing oxidation reduction. It's just attached to water. But we know in water the oxidation number of oxygen is minus 2. Right? Minus 2. Then 0 to minus 2, that's the reduction. This is the oxidation. So then the difference is 2 here. 0 minus 2, the difference is 2. Then this 2 and this 2 is cancelled. We know when we balance oxidation reduction, this 2 and this 2 is cancelled. So when we exchange the numbers also, we get the same figures. When we exchange the numbers also, we get the same figures. Right. So then it is easy to get 2 iodines likewise. Then how to balance the equation? In order to balance hydrogens, you can put 2H plus here. 2H plus here, then the equation is balanced. So now from here you can get thiosulfate moles. It is 0.002 into 25 over 1000. From thiosulfate you can get I2 moles, half of that. Then from that I2 you can get ozone. Okay, the I2 and ozone is same. Thiosulfate we have to take the half value, that's I2. And from I2 we can take ozone. So what is moles of ozone? Right? Moles of O3 you can take, it is 0.002 into 25 over 1000 into half. Then we have to get mass of O3. Mass of O3. So we can multiply it by the molar mass of O3, which is 48, right? W equal to Na. Then when we get the mass percentage, we have divided this one by the initial mass, which is 25, and multiply by 100%. That is mass percentage. Okay, mass of O3, mass percentage of O. Okay, mass percentage of O3 in air sample. So for question number 25, the answer is 1. You get answer number 1 from here is 4.8 into 10 to the power minus 3. Okay, check your answer, 4.8 into 10 to the power minus 3. So is it clear how we have balanced? Okay, so please write something, especially the redox balancing part. The good afternoon important when here we have 3 oxygens. We don't put 3 here in order to balance oxygens just before the equation, because this 2 plus this 1 will make the count equal. So we just get the difference between oxygen atoms and we have to exchange it. So if you have any issues related to redox, you can just do more questions, because this is the advanced level redox question. By doing more questions on redox, you'll be able to get the concept back. Okay, move to the next question. Why we should consider water and O2 as single compound? Because here, I mean, you can see O3 is converted to O2 and water, right? O2 and water here. So otherwise, we can't balance O3. You know, O3, if you get the composition of O3, it is like this, right? This is O3 minus and plus. So here there are 3 oxygen atoms. Definitely we have to see what had happened to those oxygen atoms. Actually here, this one of these bonds will get dissociated like this, and you get O2 from that, and the other oxygen will react with this the medium, and it is converted to water. That kind of process is available. I mean, this part is just remaining. That's what I'm saying. Okay. According to this reaction, you have to consider it as water plus O2. Water plus O2. This is the first case that they have given a question like this. You get redox balance එකතරම් පළවෙනි පාර තමයි මේක දෙන්නේ මේ ඉන්ටර්නැෂනල් බොක්ස් වලින් අරගෙන දෙන්නේ මේ questions translate කරලා. දැන් මේක කලින් එහෙම මම කියන්නේ මම එලල් කරන කාලේ මේ question එකක් මම දැකලා තිබෙන්නේ නැහැ ගොඩක් වෙලාවට. combined species එකකට redox එකක් දෙන්නේ. Is it there? Okay. Bit difficult. Oxygen atoms not balanced in the reduction. Which one? Oxygen atoms not balanced in the reduction means so the overall equation should be 2H plus O3 plus 2I minus gives O2 and water and I2, right? O2 and water. Let's balance there. Right. When you consider reduction, it's a combined equation. Then reduction this is the reduction, right? 2H plus plus 2 electrons reacts with O3 is converted into O2 and water. This is reduction. Right. So you have to balance this reduction with the oxidation. 2I minus is converted into I2 plus 2 electrons. This is oxidation. This is oxidation. How we get the 2 electrons? By considering the oxidation difference. You know, here the oxidation number is 0. Here the oxidation number of one oxygen is minus 2. 0 minus 2, the difference is 2. So you can put 2 electrons to the side with the highest oxidation number. That is here. Then in order to balance hydrogens, you can put H plus. Likewise. So then we are moving to the next question. Please take a screenshot of the question, right? And write a good review for this. Yes, next one is question number 27. Okay. 27, this one, very simple. The energy diagram of the catalyzed reaction is given here. You should understand after the doing catalysis, the activation energy is decreased. Then this activation energy means before the catalysis. Here, activation of an elementary reaction is this. This reaction is catalyzed by metal end. Then you should understand it clearly. Here, this is before catalysis. Okay. Before adding catalyst. Before adding catalyst, this is the activation. But after adding the catalyst, the activation energy is a different value. Right? It's a different value. So then you should understand according to the multi-step reaction here. Why we say it's multi-step? Because these are reactants. You can see an intermediate here. There's another intermediate here. And this is the product. So then it is a multi-step reaction after adding the catalyst. So in a multi-step reaction, what is the activation energy? Always the activation energy means gap between, right? Gap between reactants to the activation complex, right? Activation complex. It can be reactants වලින් නම් activation complex එකට තියෙන gap එක තමයි activation energy කියලා කියන්නේ. වෙන මොකුත් නැහැ. Right? So you can see this is the reactants. Right? This is your reactants. What is the activation complex? This is your activation complex. So then what is the gap between this? Can you see the gap between this? This is the gap. So when you imagine this gap, can you see what are the figures, what are the values we have to take it? And what I got E1 plus E2 here. It's incorrect, right? E1 plus E2, it will not give the gap properly, right? E1 means it's getting this part, right? Even for E2 also that part is available. So then that's not a good addition, right? All of these are energies. Even it is delta H or activation energy, all the things are energies. Then you should get the corresponding gap. So you can take delta H1 from here. And then from here, you can take E2. So there, delta H1 and E2 you can correct. Delta H1 and E2 you can correct. So that is the answer, is answer number 5. Why? Because this activation energy should be a lower value than the previous activation energy. Because by adding catalyst, we have to reduce the activation energy. Catalyst dala activation එක අඩු කරන්න නේ හදන්නේ. Then before adding the catalyst, if the activation energy is EA, after adding the catalyst, now we have found the activation energy that is equal to delta H1 plus E2, right? Delta H1 plus E2 කියලා හොයාගන්න. ඒතර මේ activation energy එක කලින් catalyst එක දාන්න කලින් activation energy එකට වැඩිය definitely මොකක් වෙන්න ඕනද? අඩු වෙන්න ඕන. ඒ නිසා තමයි answer එක 5. right? හොඳයි ඔන්න 27 එක හොඳ review එකක් එහෙම ලියන්න. right? Activation energy means the gap between reactants to the activation complex. It's the top of the mountain. I think we have to discuss question number 28 also. Right? 28 එක discuss කරන්න ඕනේ නැද්ද? So that's a Henderson equation, right? That's Henderson equation. 28 discuss කරන්න මොකද? නැත්නම් 28 ඕන වෙයි. 29 30 තමයි කියලා තියෙන්නේ. 29 එකේ answer එක 5 එක මට අගලා කියන්න. Small covalent molecules are eliminated when the monomers combine to form condensation polymers. ඉතින් මේක හරි. Right? Condensation polymerization means removing small molecules, right? So what are the 4 condensation polymers we have? Number 1, bakelite, phenol formaldehyde. When phenol formaldehyde is formed, phenols and formaldehyde molecules will get together, releasing water molecules. Number 2, urea formaldehyde. It will release water molecules. You see my polymers lesson, right? Then number 3, polyesters. So then when a carboxylic acid is treated with an alcohol, it is releasing water. Right? That is formation of a polymer by removing water molecule. It is called condensation polymerization. We have 4 types of condensation, four condensation polymers. Phenol formaldehyde, urea formaldehyde, polyesters, and polyamides. So actually polyamide means nylon. Polyamide means nylon. So when you form nylon also, what will happen? HCl or water molecule is liberated. Small molecule is liberated, water or HCl, right? So then the answer is answer number 5 here. Nylon is addition polymer. And nylon කියලා කියන්නේ polyamide වලට. මේක condensation polymer. Teflon is a condensation polymer. And Teflon can addition polymer. Double bonds වලින් තමයි add වෙන්නේ. Polymerless අනික බලන්න. Bakelite is a linear polymer. 3D polymer. 3D polymer. The number of carbon atoms in a repeating unit of natural rubber is 4. Now, natural rubber වල carbon atoms 4කට වැඩිය තියෙනවා because this is the repeating unit of natural rubber, right? CH2 double bond C, you have CH2 isobutene වල තමයි හැම වෙන්නේ. මේ තමයි natural rubber. There's a double bond also. This is the repeating unit of natural rubber. Okay, so there are more than 4 carbon atoms. Answer is 5, right? Question number 30 ගත්ත අහලා තියෙනවා. Two ideal gases that do not react with each other separated by a valve and kept in a rigid container. Again, ideal gases දෙකක් මෙහෙම වෙන වෙනම තියලා තියෙනවා, right? Two ideal gases. The system is maintained at constant temperature and pressure. Temperature and pressure is constant. Which of the following correctly describe the Gibbs energy and enthalpy and entropy when the valve is open, right? So when you open the valve, the gases will mix, right? Gases will mix each other. So then this gas is A. Okay, we get another gas. Let's get gas B here, right? So when you open this mixture, you get gas A and gas B. It's a mixation, right? I mean, the mixation will happen. The gases will move here and there. They will not react. They will not form any bonds, but they will mix. So then as there's a mixation, as they will mix each other, we can say there's a reaction. I mean, there's a process, right? So we would say delta G is minus because the mixation will take place, right? And then clearly what will happen to delta S value. It is getting positive because randomness is increasing, disorder is increasing, right? Disorder is increasing. But what should happen to the delta H value? Delta H value is not changed, right? Delta H value is, it depends on the temperature. Right? Delta H value එක උතන දැන් temperature එකත් එක්ක තමයි අපි consider කරගන්න වෙන්නේ. When these species are mixed, what will happen to the delta H value? Delta H value means the gap between reactants and products, right? Now just think there's a reaction. So we should have reactants and then we have to have products. So if we get the gap between reactants and products, that is called delta H value, right? Delta H value. So then there's no reaction here, just a mixation, right? Only you have reactants even after mixing. When we say delta H value is unchanged, so for question number 30, they have given the answer as answer number 3, right? Question number 30, answer number 3. Decrease, unchanged, increased. Clear? Then why it is taken like that? Because you can clearly understand when you consider the species here, they will mix each other. A will mix with B, but mixation means not producing any products. Just randomly they will arrange. If A and B will react to form any product, that's a mixation and that's a reaction. Then you have reactants and you have products. So then the energy of reactants and products will be different. When the energy of reactants and products will be different, there's an enthalpy change. Because enthalpy change means the gap between the products and reactants. Okay? So then we don't have any enthalpy change as there's no gap between reactants and products. That's the answer for that question. Right? You can write a small review for this question number 30 there. Okay. Any issues? Please ask your questions. Gibbs do not react in question. How we can say Gibbs energy decreases? Actually, Gibbs energy decreases කියන එක නෙමෙයි මෙතන අර idea එක. හරි. මේකේ sign එක තමයි මේ කියන්නේ change in Gibbs energy. හරි. Change in Gibbs energy. Now we know that the delta G value is a negative value, right? Delta G value is a negative value because there's a spontaneous process. Isn't it? Now we have gas A, gas B, when we open the tap, we don't mix these gases forcefully. We don't give an electric current to mix these gases. They will mix, right? They will mix. හරි නිකන් මේ පැත්තේ මාළු ටැංකිය දෙකක් එහෙම තියාගෙන මැද්දෙන් අපි පොඩක් මේ මාළු ටැංකිය දෙක මැද්දෙන් කනෙක්ට් කරනවා. මාළුන්ට මික්ස් වෙන්න පුළුවන්. ඒත් අපි බලෙන් මේ මාළුව තල්ලු කරන්නේ එහෙම කියලා තල්ලු කරන්නේ. හරි. ඒත් මේ පැත්තේ ඉන්න කට්ටිය මෙහෙට එනවා. මේ පැත්තේ ඉන්න කට්ටිය මෙහෙට එනවා. අපි යන්නේ කිව්වෙත් නෑ. හරි. I mean, that's a spontaneous process. Then when there's a spontaneous process, we know delta G value is a negative value. Right? Delta G value is a negative value in that case. මෙතන අර sign එක තමයි යහන්නේ. දැන් delta is positive. හරි. positive එක තව increase වෙලා කියන idea එක කියන්නේ. එන්න increase වෙනවා. Delta G එකේ the mixation will take place. So then greater the mixation, increasing the delta G value. Right? එහෙම idea එකක් තමයි ඒකේ තියෙන question. Right? So ටිකක් හිතන part එකක් තියෙනවා question. නැත්නම් නේ. Okay. This question 28, what is the answer? I think I have to discuss 28 also. But here 28 के answer का 5. How you get this answer 5? Okay. This is Henderson equation, pH, right? This is Henderson equation is pH. Actually, when we get the Henderson equation, we can understand F means amount of acid dissociated over amount of acid undissociated. Just think this species with a weak acid, like what is weak acid having here? CH3COOH. You know, it will dissociate to give CH3COO minus plus H plus. So what is the amount of acid dissociated? There is CH3COO minus. What is the amount of acid undissociated? It's the remaining amount, which is CH3COOH. So they are asking a ratio between this. It is given as F. Okay. Now we make a Henderson equation in common. Right? How to take this one using Henderson equation? So CH3COOH dissociates to give CH3COO minus and H plus. C minus X, X, and then this X. CH3COOH. This is acetate and H plus. Right. Then here Ka is equal to CH3COO minus into H plus over CH3COO. Okay. So here they are asking the relationship with the pH, so we can directly get the pH relationship. pH is equal to pKa plus log 10 salt of acid. pH is equal to pKa plus salt of acid. मैं Henderson equation का weak acid एකට apply कराने පුළුවන්. මම apply කරා. So then this is CH3COO minus over CH3COOH. There CH3COOH. මේක තමයි question එකේ කියන්නේ amount of acid undissociated over amount of acid dissociated. Dissociated means acetate. This is dissociated. This is undissociated. Undissociated. Then the ratio between dissociated over undissociated is called F. When dissociated over undissociated කියන එකට තමයි අපි F කියන්නේ. So you will get pH is equal to pKa plus log 10 F. pH is equal to pKa 10 log F. ඉතින් මේ ඔයගොල්ලෝගේ graph එකේ answer sheets වල තියෙන්නේ කොහොමද කියලා බලන්න. මේකට ඒකට ඕන විදිහට හදන්න බෑ. එතකොට y axis එක log F, x axis එක pH. Right? So y equal to mx plus c, mx minus c. So then we keep this log F here, right? And we put this pKa here minus pKa plus pH. And then make a shape එක කොහොමද කියන්නේ? y equal to, and then y equal to, this is mx plus mx minus c. Plus mx minus c. So when we draw the graph, this is log F. Log F. Okay. mx plus c. mx minus c. So minus c will end up ZA minus pKa plus X. pH. That's how we interpret the graph. The answer is answer number 5. So for a weak acid, easily you can get amount of acid undissociated over undissociated over dissociated, dissociated over undissociated. Is it it? I mean, this part you can take it as log F, and log F we can make it Y, then Mx minus C. Mx minus C is the graph. Right? So by applying Henderson equation, we can directly attend to the question easily. Even it's a weak acid, weak base, or it's a buffer solution, the Henderson equation is really available, right? Applicable for all these steps. Right. Next one. Answer is 5. We have to discuss this pH question now. A buffer solution pH 5 was prepared by mixing equal volume of 0.1 monobasic weak acid and 0.1 solution of the sodium salt of this acid. This is really important. Right? The pH of the resultant solution when 20 cubic centimeters of this buffer solution was mixed with 90 cubic centimeters of 0.1 weak acid solution. Okay. Read the question twice or thrice. Right? Question 25. Question make it 21. Right. So here they have given the answer as answer number 2, and we got answer number 2 here. Even in 2021 A-level paper also, there was a question like this, buffer. Right. So you can see from the pH lesson and the buffers lesson, this paper is affected to a certain extent, great extent. Because the first essay question, some critical MCQs, right? Available from pH. Right. First of all, you have to understand in this question, question number 21, a buffer solution of pH 5 was prepared by mixing equal volumes of 0.1 monobasic weak acid. So then the monobasic weak acid, you can take it as CH3COOH. CH3COOH is the monobasic weak acid. It is 0.1. Okay. And then the sodium salt. The most important thing is when you mix this, right, CH3COONA 0.1 m and then CH3COOH, you are mixing like this, right? And you are making a solution. So then here V and here V. The final volume is 2V. You know, when equal volumes are mixed, the concentration will become half. Right? So you can understand C1 V1 equal to C2 V2. Just apply this equation for this acidic. So then initial concentration is 0.1. The initial volume is V, but you know the final volume is becoming 2V. So then we can take what would be the concentration of that. Right? So when the final volume is C2, what is the concentration of that? So definitely CH3COOH, the concentration of CH3COOH is 0.1/2, which is 0.05. CH3COOH is 0.1/2, which is 0.05. And then again CH3COONA, it is also 0.05. After mixing, these are the concentration. Here, you can notice කරගන්න ඕනේ. ඊට පස්සේ මෙහෙම දීලා තියෙනවා. So මේකේ pH එක 5 කියලා කියලා තියෙනවා. The pH of this solution is 5. හොඳයි. අනිත් අපි මේකට equation එකක් ලියන්න පුළුවන් Henderson equation. We can write pH is equal to pKa plus log 10 salt over acid. Salt over acid 0.05 over 0.05. Right. So the pH is 5. So you can see this is cancelled. Log 1 is 0. Log 1 is 0. So that means pKa is equal to 5. pKa को 5 කරන්නේ කියන්නේ. එසේ මෙන්න මෙහෙම කියනවා. The pH of the solution when 20 cubic centimeters of this buffer was mixed. And then buffer again 20 cubic centimeters ගන්නවා. Right? I mean you have to take 20 cubic centimeters of this buffer. Right? අන්න ගන්නවා 20 cubic centimeters of this buffer. So in this buffer what we have CH3COOH having the concentration 0.05 m. And then we have CH3COONA. CH3COONA concentration is again 0.05. Clear? Okay, case. So we have 20 cubic centimeters. What you do? First mix with 90 cubic centimeters of 0.1 weak acid. Right. So you're adding 90 cubic centimeters of 0.1 m the weak acid CH3COOH to this. Diagrams are really important. Even in the first essay question, this experience is really important. Right? Even in the first essay question. So then here, for that part, we can apply the Henderson equation again. pH is equal to pKa plus log 10 salt over acid. What is the salt concentration? So get the number of moles of the salt divided by total volume. The salt moles again total volume again bedan. What is the number of moles of salt? You know, salt is CH3COONA. So when you add acidic, there's no improvement of the number of salts. Salts වැඩි වෙන්නේ නැහැ acidic add කරාට. Acidic කියන්නේ weak acid එක. ඒතර acidic වලින් add වෙන්නේ acidic moles. ඒතර salt වල moles වෙනස් වෙනවද? නැහැ. ඒතර concentration වෙනස් වෙනවද? ඔව්. ඇයි? Total volume එක වෙනස් වෙනවා. Here you have only 20 cubic centimeters. When you add 90 cubic centimeters to this, the total volume will become 110. So what is the salt concentration? In order to get the salt concentration, first get the number of moles of salt in 20 cubic centimeters. 20 cubic centimeters in salt moles එක ගන්න. අරගෙන total volume එකෙන් බෙදන්න. Apply N equal to CD, right? So for sodium acetate, you can apply N equal to CD, right? So you know number of moles of acidic is 0.05 into volume. Here volume है, right? What is 20 into 20 over 1000. 0.05 into 20 over 1000. This is the number of moles of acidic. So this number of moles is remaining same, right? Even you are adding CH3COOH to that. Meaning sodium acetate moles again. So 0.05 into 20 into 10 to the power minus 3. This is the number of moles of acidic divided by total volume. Total volume is 110. From the 110 in 90 plus 20. Right? This method again and it's salt over acid. Acid එක. අන්න acid එකේ moles එක තමයි වැඩි වෙන්නේ. Acidic ඉන්න එකකට තව acidic add කරනවා. එතන moles වල addition එක ගන්න. N equal to CV ලියන්න. හරි? 0.05 into 20. ඒ තමයි තියෙන amount එක. add කරන්නේ කොච්චරද? 0.1 into 90. මේ දෙක ලියන්න. හරි? 0.05 into 20. හරි. over 1000 නැත්නම් 10 to the power minus 3 ලියන්න පුළුවන්. මේ 10 to the power minus 3 ඔක්කොම capital යනවා. Plus අනිත් එක නාර add කරන amount එක 0.1 into 9 into 10 to the power minus 3. Right? 0.1 into 90 into 10 to the power minus 3. Clear? Divide by total volume. Right? එතන total volume එකෙන් divide කරන්න. Because we are applying pH equal to pK salt or acid. Salt concentration or acid concentration. So the total volume is 100. බලන්න cancel වෙන විදිය. 110 110 එක cancel. මේ 10 to the power minus 3 ආව ගන්න පුළුවන් ඉස්සරහ. bracket එකකින් එළිය. So 10 to the power minus 3 ටිකත් ඔක්කොම cancel. ඒක බලන්න වෙනද? We know pK කලින් කියන pK value එක දන්නවා pK 5 කියලා. temperature වෙනස් වෙන්නේ නැත්නම් pK වෙනස් වෙන්නේ නැහැ. log 10 one expression එක 0.05 into 20. 0.05 into 20 කියන්නේ කීයද? 20 into 5 over 100. හරි. සර් එකයි 100 5. හරි. 5 over 5 කියන්නේ 1. ඊට මෙතනත් එන්නේ 1 plus 9. එකද expression. 25 කළා බලන්න. හරි. 1 over 10. That is 10 to the power minus 1. So then pH is equal to 4. pH is equal to 4. Right. So then we can clearly understand the answer is answer number 2. Is it clear? බලන්න මම explain කරපු එක clear ද කියලා. Please raise your hands if it is okay with you. This part is critical. Right? Because here what you have to do, you have to get the salt concentration. pH equal to pK plus log 10 salt of acid. Methane salt concentration. Methane තමයි salt එක ගත්තේ. 0.05 into 20. Most over total volume. Total volume means after adding 90 cubic centimeters of acidic, the total volume will become 20 plus 90. That is 110. Right? 110. That's what I have divided like this. Right? Divided like this. Just see that expression. Okay? Expression එක හොඳට බලන්න. This expression. This part is really important. I'll write it here if you want. Log 10 0.05 into 20 over 1000. 20 into 10 to the power minus 3, the moles over 110. That is the concentration of the salt. Salt concentration. Divided by the acid concentration. This 0.05 into 20 into 10 to the power minus 3 plus another thing add करने के 0.1 into 90 into 10 to the power minus 3 over the total volume 110. Right? So this is the concentration of acid CH3COO. So we are applying Henderson equation twice to the initial mixture and to the final mixture. pH equal to pK plus log 10 salt of acid. Is it there? Just write it properly. Then start karana. First write this one. Then draw the diagram. Then apply the equation again. After drawing this diagram, apply this equation again. From this mixture, you get only 20 cubic centimeters. In this mixture, I have mentioned the concentration. My concentration is mentioned kala thiyene my mixture. Okay. This mixture. Okay, please raise your hands if it is clear to you. Right. You can add a photo of this to your WhatsApp group also, right? Photo hai check karana. Just write it. Right, okay. So I've discussed that question. I'll be sending a proper MCQ review with this. On MCQ review, so then all the 50 MCQs are completely reviewed in that paper, in that one, Sarasabi MCQ review book, right? So then please write a review for all the 50 MCQs. So then, we are discussing MCQs from 2016 A-level paper, 17, 18, and this is 19. Next one is 20 and 21. So if you can write all the reviews for all the 50 MCQs, that would be a great effect, right? Maybe you will achieve a B pass if you can do the past papers well, right? All the past papers well, at least 2 times. We're not stopping from past papers. We will be moving to term test papers and module papers in upcoming sessions, right? Yes. So then I have discussed all the questions from 21 to 30 as you have suggested, right? All the questions I have discussed. My next target is 31 to 40. Sorry, 41 to 50. So send me 41 to 50, and I'll be moving to structural essay paper and coming back, right? 41 to 50. Okay, board එක clear නැහැ photo එක add කරන්න කියලා මම add කරන්න. හරි. චුට්ටක් බලන්න screenshot එකක් හරි ගන්න බැරි වේද කියලා. Right. මම add කරනවා. හරි මම 41 to 51 41 to 50. 30 වෙන්න එපා. 41 to 50. 41 to 50 මුලින් කතා කරන්න. Statements. This one. Right, we'll discuss this. These are the suggestions. 49, 50, 44, 44, 45, 41, 41, 48. And right. Right. Okay. First of all, question number 50. Although CFC contribute to the ozone layer depletion, the contribution of HFC is negligible. Right. So for question number 50, the answer is all here. They have given all. Why the answer is all? Right. I mean, answer all when general answer right. මේ term එකේ ප්‍රශ්නයක් හඳ තමයි answer එක all වෙන්නේ නැත්නම් answer එක 5 වෙන්නේ. කියන්නේ answer එක අපිට 5 කියලා ගන්න පුළුවන්. answer එක all වෙන එක ප්‍රශ්නේ ඔයගොල්ලන්ට තියෙන්නේ. හරි. So then actually negligible means what is negligible? Negligible කියන term එකේ තමයි ප්‍රශ්නයක් තියෙන්නේ. හරි. මේක negligible නෙමෙයි මේක 0 වෙනවා. The contribution from HFC is 0. Right? Should be 0, not negligible. Then because of that confusion, they have given the answer as all. That's the meaning of that part. However, the answer is answer number 5. Both statements, although CFC contribute to the ozone layer, the contribution of HFC is negligible. There are negligible කියන එක තමයි කියලා ඒක 0ද කියලා කියලා නැති. හරි. However, HFC undergoes complete decomposition before reaching the upper atmosphere. Before reaching the upper atmosphere, right? So when you consider the first statement, then මෙතන පොඩි හරි negligible කියලා කියන්නේ පොඩි effect එකක් තියෙනවා කියන්නේ. Negligible but it is 0. ඒකයි statements දෙකම වැරදි answer එක 5 කියලා කියන්නේ. Right. ඒකයි statements දෙකම වැරදි answer එක 5 කෙවේ. Give me 1 minute. Erasing the board, right? In ozone layer depletion, we have to have fluorine radicals in order to deplete ozone. man and environment. Okay, this chlorine radicals will break oxygen to OCl and you get O2. This O2 is dissociated to free radicals like this, and one of the free radicals will react with OCl, right? And then it is converted into O2 plus chlorine radical. This chlorine radical will again deplete ozone. This is called catalytic depletion of ozone layer. Catalytic depletion of ozone layer. So actually, in order to deplete, you have to have chlorine radicals. But when you get CFC, chlorofluorocarbon, you have chlorine radicals. Okay, hydrofluorocarbon, HCFC, right? CFC and HCFC, they are having chlorine radicals. Chlorine radicals are available. But in HFC, we have carbon and around carbon, hydrogen and chlorine only. Right? We have hydrogen and chlorine only. So there's no chlorine radicals. Chlorine radicals nahan. Chlorine radicals nahan. So because of that, as there's no chlorine radicals available, there's no effect to ozone depletion. You can't say even negligible. Negligible means there's an effect, it is not considered. Right? It cannot be considered. But there's no effect. Right? Zero. Here, again, first second, when HFC is moving to upper atmosphere, it is undergoing complete decomposition, dissociation. In HFC, we have CH bonds. And CH bonds are weak bonds. Actually, then when they are moving to upper atmosphere, they will absorb the energy and the bonds will get dissociated. Okay? And you consider CH4, CH3, these CH bonds are having weak bond strengths. Bond strength is comparatively high. Then when they are moving to upper atmosphere, they will absorb the energy from IR rays, then it is dissociated. But we can't say completely dissociated. Completely dissociated because we don't know whether it's completely dissociated or partially dissociated. We can't exactly say it's 100% dissociated, and that's the expected answer. Okay? So then that's what we say answer is 5. So they have given all, right? For that confusion. Right, okay, that's question number 50. My explanation. Try to take a screenshot if you want. Right? And you can write about this. Whether me man and environment can yeah. Notes balla, recordings balla yeah. Unga kaya me lesson ekot kaam cover karenge. Questions karlat nahi. Short note ekat nahi. Right? The අපේ classes වල lessons cover කරලා papers උත් කරලා මේවා questions discuss කරලා ගොඩක් දේවල් කරලා තියෙනවා. ඉතින් please try to use that knowledge that we have developed, right? Okay, next one. Question number 49. Any two ideal gases have same average kinetic energies at same temperature? Oh, this is the case. For question number 49, the answer is 1. Okay, this and this. The average speed of molecules is just according to their masses, right? So why the answer is 1? Any two ideal gases have same average kinetic energies at same temperature. So average kinetic energy is E bar. E bar. So we can get E bar value, right? E bar is equal to 3 over 2 kT. E bar is equal to 3 over 2 kT. The mean kinetic energy is proportional to temperature. Case Boltzmann constant. Gas loss, right? So when temperature is constant, average kinetic energy is constant. Question number 50. Right? What we can say, any two gases have the same average kinetic energies at same temperature. Yes, at the same temperature they have same kinetic energies. That is same. Okay, that is true. First statement is true. Second one, at a given temperature, the average speed of gas molecules adjusts according to their masses. Right? According to their masses, at a given temperature, the average speed of gas molecules adjusts. So then there's an equation for this. C squared bar is equal to 3 RT over capital M. Right? So then when you get the average speed, you can get the square root of this, right? And you will be getting an average speed. Okay. Generally, C squared bar is converted to C bar, not directly, right? Roughly it's converted. And then there's a relationship between molar mass and temperature, right? I mean, when you change the molar mass of the gas, right? C bar is changed. At a given temperature, the average speed of gas molecules adjust according to their masses. So when the mass is changed, the average speed is changed, right? Or the average, the kinetic energy is equal to half mv squared. Half mv squared. At a given temperature, at a given temperature, the kinetic energy is not changed. E bar. The temperature වෙනස් වෙන්නේ නැත්නම් kinetic energy වෙනස් වෙන්නේ නැහැ. Right? So then what you have to understand, when mass is increased, the volume, the velocity is decreased. The velocity is increased, mass is decreased. If remember, when temperature is constant, the kinetic energy is constant. Right? So then if kinetic energy is constant, the velocity is adjusted, or the speed is adjusted with respect to its mass. Right? So these are the two equations you have to use mainly. So then the answer is answer number 1. Right? Answer is answer number 1. You can write a comment for that part. It's question number 49. Next one, 48. Carbon and carbon atom of a ketone and other atoms bonded to it lie in the same plane. Right? Very simple. Okay. Just draw a ketone, CH3, COCH3. Right? Carbon and carbon atom of a ketone can be carbon and other atoms bonded to it. Other atoms bonded to it, all the other atoms. Carbon atoms, never. 48 එකට answer to 1 දීලා තියෙන්නේ. Carbon atom of a ketone and the other atoms bonded to it කියලා කියන්නේ carbon ට bond වෙනවා. ඉතින් පොඩ්ඩක් අර realize කරගන්න එකේ ප්‍රශ්නයක් තමයි තියෙන්නේ. Other atoms bonded to it means bonded to carbon. ඔයගොල්ලෝ බලන්න ඕනේ මේ it කියන්නේ මොකක්ද කියලා. It කියන්නේ carbon කියන්නේ. Okay? It means this carbon. So then this is bonded to this carbon, this is bonded to this carbon. මේ hydrogen bond වෙලා නේ. Hydrogen bond වෙලා තියෙන අනිත් carbons වලට. So then when you consider hydrogens, they are lying in different planes. Tetrahedron. Right? These hydrogens are lying in different planes. But when you consider the carbonyl carbon atom, the oxygen and this, okay, the atoms bonded to this carbon, they are lying in same plane. There is 2. But carbonyl carbon atom of a ketone is sp2 hybrids කියලා. This acid is sp2 hybrids, they are lying in the same plane. Okay. Hybridization explains the structure. Hybridization explains the structure. So then the answer is 1. Mention it properly. Right? So in 48 is also answer is 1. So for 48 also the answer is expected answer is 1. Right. Actually, we can explain the second statement. I mean, second statement is explaining the first one, right? Second statement again is first explain that E bar equal to that relationship. Furthermore, it's a 49 dilatin 1 කියලා. So the next question is 40 45. Solubility of 1 butanol in water is less than the solubility of methanol in water. Very simple. Solubility depends on mass. Both methanol and butanol make hydrogen bonding, right? Then methanol means CH3OH. 1 butanol means there should be 4 carbon atoms. This is 1 butanol. Then the solubility of methanol is high, solubility of butanol is low. Why? Why the solubility is low? Because the mass. Higher the mass, lower the solubility. Both of these are polar. They have hydrogen interactions. They are dissolving in water well. But when you're comparing these two species, the species is having high mass, low solubility. Mass එක වැඩි වෙන නිසා තමයි මෙතන නම් solubility එක අඩු වෙන්නේ. ඉතින් question number 45 එකට අපිට answer එක දීලා තියෙන්නේ 1 කියලා. එතන second එකෙන් first එක explain වෙනවා. Right? Answer එක 1. ඇයි? The solubility of alcohols in water decreases as the size of non-polar alkyl group increases. එකද? size එක වැඩි වෙනකොට mass එක වැඩි වෙනවා. Okay, 44. Spontaneous reaction always has a negative Gibbs energy change no matter what the conditions are. Right? You can't say always a spontaneous reaction is having negative Gibbs energy. Now just think calcium carbonate dissociates to give calcium oxide plus carbon dioxide. In this reaction, what is delta H and what is delta S and what is delta G? Right? You know, this reaction is exothermic. This reaction is an endothermic reaction, right? I mean, we have to decompose calcium carbonate by supplying heat inside the hunuporanu or kiln එකක් කියලා කියන්නේ. අපි දර දාලා හරි heat එක දීලා. So we have to decompose calcium carbonate. So it is an endothermic reaction. You know, in this reaction, delta S is positive. Solid gas. So we know when delta H and delta S is positive, when delta H and delta S is positive, what will happen to the delta G value? Right? So then the delta G value will become negative. So then this delta G would be negative, especially at low temperatures. We know the delta G is negative at high temperatures. So only at high temperatures, this reaction is spontaneous. So the reaction is calcium carbonate decompose in 900 Celsius. Around 900 Celsius, this reaction will take place. Right? At 900 Celsius, the reaction is spontaneous. But if you get like 25 Celsius, we could say the reaction is non-spontaneous. Delta G is plus. So 25 Celsius for delta G is plus. Non-spontaneous. Then understand the again of the reaction label delta G negative like spontaneous. Okay. Depending on the temperature, there are some reactions that the delta G negative value could be a positive value. I mean, a spontaneous reaction could be converted to a non-spontaneous reaction depending on the temperature. Okay. But there are some reactions that we have always spontaneous nature. Right? You know that you know this table, right? Delta G delta stable like a balance. Always spontaneous, high temperature spontaneous, low temperature spontaneous, and non-spontaneous. We have 4 events, right? Okay. So for question number 44, they have given the answer as answer number 4. First one is incorrect, second one is correct. Why second one is correct? Gibbs energy change can be used to predict the direction of the reaction only under constant temperature and constant pressure conditions. Wait a minute. When the temperature is changed, delta G value is changed. Right? Then you should know properly what is the temperature, what is the pressure. Then you can imagine that temperature and pressure as a high temperature or high pressure. Depending on that, you can get the delta G value and predict your answer. When delta G is negative, it's spontaneous. Delta G is positive, it's non-spontaneous. Spontaneous means automatically happening. Reactants are converted into products. Right? It depends on the temperature. Right? So when delta H and delta S is positive, it's spontaneous at high temperature. When delta H and delta S is negative, it is spontaneous only at low temperature. But when delta H is negative and delta S is positive, it is always spontaneous at any temperature. There are 3 events the spontaneity will take place. Okay, so then that is the answer for that question. Yes, so then question 41 you are asking, among halogens, I2 is a solid gas, Br2 is a liquid. Yes, that's a well-known thing. London forces become stronger with increasing the molecular surface area. That is true. London forces will depend on 2 factors, mass and surface area. Right? The London forces depend on mass and surface area. Right? Higher the surface area, higher the London forces, higher the mass, higher the London forces. Actually, this is explaining the answer. Answer is answer number 1. Right? Answer is answer number 1. Right? Why it is explained? Because when you move downwards, you know, fluorine, bromine, iodine. Right? Higher the surface area. Right? Surface area increase when fluorine chlorinal radius වැඩි, bromine, iodine. Higher the surface area, we say higher the London forces. Right? Then the strength of London forces will increase. Right? Strength of London forces will increase. London forces will strength එක වැඩි වෙනවා. I think London forces will strength depend on factors දෙකක්. Right? One of the factors දෙක area එකයි mass එක. ඔය විදිහට. mass එක වැඩි වෙනකොට වැඩි වෙනවා, area එකත් වැඩි වෙනවා. Area means surface area. Right? Should understand this point. CH3, CH2, CH2, CH2. Right? CH3, CH2, CH2, CH2. You see, we have high surface area here. High surface area. linear, unbranched, high surface area. Surface area එක වැඩි වෙන්නේ branch ගතිය අඩු වුණා. This is CH3, CH, CH3, and here we have CH2. Again CH3, here CH, CH3 and CH2. Can you see? Like this. So they have branch, less surface area. මෙතන surface area එක අඩුයි. මෙතනදී surface area එක වැඩි. Yeah. I mean, when you consider boiling points, they have higher balance. Right? When it is branch, surface area get decreased. Keep remember. Right? Branch වෙනකොට surface area එක අඩු වෙනවා. මේ විස්තර ගොඩාක් ලියන්න පුළුවන් මේ question. Question number එක. ඒත් MCQ එක discuss කරාම MCQ 50ම review එක ලියන්න. Structure එක check කරගෙන හැම එකම 100 වලින් marks දාගන්න. ඊට පස්සේ essay perfect කරන්න. මම හිතනවා මේ වැඩ ටිකට සාමාන්‍ය පැය 5ක් එක week එකකට යනවා. ඊට වැඩි යන්න පුළුවන්. හරි. ඊළඟ perfect කරන්නත් ඕනේ. කලින් paper review එකක් ලියන්නත් ඕනේ. හරි. ඉතින් ඔය ටික කරගෙන යද්දි හොඳයි. කිසිම කලබලයක් වෙන්න දෙයක් නැහැ. තව මාස 4ක් 5ක් අපිට තියෙනවා. හරි. තාම මේ ඔගස්ට්නේ. සැප්තැම්බර් ඔක්තෝබර් නවැම්බර්. ඔය මාස තුන අනිවාර්යයෙන්ම තියෙනවා. නොවැම්බර් 28 නේ කිව්වේ. කලින්. හරි මාස 3ක්ම තියෙනවා. මාස 3ක් කියන්නේ දවස් 90. එහෙම හිතන්න. හරි මට දැන් මුක් කරගන්න බෑ. එහෙම හිතන්න එපා. 90 days. දවස් 90. ඉතින් මම කියන්නේ හොඳ රිවිව් එකක් ලියන්න. වැඩ ටික හොඳට කරන්න. Right? Okay. Now මට මෙන්න මේ 42 එක discuss කරන්න අපි කිව්වේ at a given pressure spontaneity of the reaction between N2 and ammonia drops with increasing temperature. ඒකත් හරි. Right? Because in that reaction also when you react N2 with H2 to form ammonia, it's an exothermic reaction. Delta H minus. Right? So then here collect the gas molecules. Here we have 4 gas molecules. Here we have 2 gas molecules. Delta S is negative. So when delta H and delta S is negative, you know reaction is only spontaneous at low temperatures. Right? Reaction එක spontaneous වෙන්නේ low temperatures වල විතරයි. When delta H is negative, when delta S is negative, reaction is only spontaneous at low temperatures. At low temperatures, it becomes spontaneous. At high temperatures, it is non-spontaneous. It is non-spontaneous. Right? So then what you have to understand, when increasing temperature, the spontaneity will get decreased. Right? So 42 එකටත් මේගොල්ලෝ answer එක දීලා තියෙන්නේ 1. මේක answer 1 නේ වැඩි. හරි. Second statement will explain. Right? Entropy change of the reaction between N2 and M2 is negative. මේ entropy change එක negative වුණ නිසා තමයි මෙහෙම වෙන්නේ. Entropy change එක positive වුණා නම් ඔය දේ වෙන්නේ නැහැ. Right? Entropy change එක negative වෙන නිසා තමයි මේ condition එක වෙන්නේ. Low temperatures විතරක් spontaneous. Right? If entropy change is positive, it is spontaneous even at high temperature. Yeah? Okay. So you can write a good review for that. Right? Then we'll discuss 31 to 40 also. Just tell me 2 questions, right? Most essential questions 31 to 40, because we will have to move to the structured essay paper. 31 to 40, right? Okay, 34. That's one of the good questions. Yes, I can explain 34. The others you can manage, I think, right? So you can see question 31. Okay. 34 එක අපි කතා කරමු. ඒක හොඳ question එකක්. මේක pH question එක. pH වැඩි මේ පැත්තේ. Which of the following statements are correct regarding the precipitation of metal ions when passing H2S into their solution? හොඳට කියවන්න question 34. 34 සුපිරි question එකක්, right? So 34 එකේ answer එක 2 තියෙන්නේ BC correct. අන්න ඔයගොල්ලෝ answer එක ගන්න පුළුවන් වුණාද කියලා. හරි. ඔයාලා අහලා තියෙන්නේ correct statement එක. Just check it. Right. So this is 34. Have a discussion on this. Which of the following statements is are correct regarding the precipitation of metal ions when passing H2S to aqueous solutions? Right. Okay. So if we pass H2S gas to an aqueous solution, it will become H2O liquid, H2S liquid, right? H2S aqueous. However, when the pressure of H2S gas is decreased, the sulfide ion concentration is increased, right? Actually, the first statement is incorrect. Why? Because you know P equal to CRT. When we increase the pressure, the concentration is increased. Pressure එක වැඩි වෙනකොට තමයි concentration එක වැඩි වෙන්නේ. ඉතින් මේගොල්ලෝ කියදින් pressure එක decrease කරනවා කියලා. So when you decrease the pressure, the concentration is getting decreased. So when the concentration of H2S is getting decreased, H2S aqueous, H2S gas එක වතුර දියුණාම මේක අපි කියනවා H2S aqueous කියලා. මේක exothermic reaction එක. Right? When a gas is dissolved in water, that reaction is exothermic. You remember that. Right? So then H2S aqueous is dissociated to give H plus and HS minus initially. Then HS minus furthermore dissociates to give H plus and H2 minus. So if we have high concentration of H2S, we have high concentration of H2 minus. H2S වැඩි වුණොත් තමයි H2 minus වැඩි වෙන්නේ. So H2S අඩු වුණොත් H2 minus උත් අඩු වෙනවා. A is equal. B එක correct. When the temperature is increased, sulfide ion concentration is decreased. How it will happen? This is the reason. Every gas dissolves in water. That's an exothermic reaction. So when you decrease the reaction, when you decrease the temperature, what will happen? Right? අන්න එක තමයි case එක. අපි temperature එක decrease කරනකොට තමයි exothermic reaction එක favor වෙන්නේ. Right? Exothermic reaction එක favor වෙන්නේ. ඒ කියන්නේ gas එක හොඳට වතුර දිය වෙනවා. H2S gas හොඳටම වතුර දිය වෙන්නේ temperature එක අඩු කරනවා. හරි. cool වෙලාවට තමයි gases හොඳටම වතුර දිය වෙන්නේ. ඇන්ටාර්ටිකාව වගේ පැත්තේ හරි. oxygen gas එක ඕන තරම් වතුර දිය වෙලා තියෙනවා. අපේ oxygen percentage එක වැඩි. cool වෙලා. hot වෙලාවට heat වෙලාවට දවල්ට හරි වතුර තියෙන oxygen percentage එක අඩුයි. ඒක තමයි මාළු වෙන්නේ උඩට හුස්ම ගන්න. හරි. Right. So then when temperature is decreased, exothermic reaction is favored. And then the exothermic reaction is favored. So then we can say sulfide ion concentration. We can say the sulfide ion concentration is increased. I think sulfide ion concentration increased. What about C? Addition of sodium sulfide to the solution decreases the dissociation of dissolved H2S. Okay, if we add sodium sulfide, we know sodium sulfide is dissociated to give two sodium ions and sulfide ions. You can see from here sulfide ions will increase. I mean the content of sulfide ions will increase. So as the content of sulfide ions will increase, system is trying to decrease. So then that is okay. I mean, you know, H2S is dissociated to give H plus and H2 minus. So when the content of sulfide is increasing, system is trying to decrease it by favoring the backward reaction. The backward reaction favor the dissociation of dissolved H2S decreased. H2S dissociate H2S form way. Right? So addition of sodium sulfide decreases the dissociation. Increase the pH of the solution, decreases the sulfide ion concentration. Increasing pH means okay, decreasing H plus. pH H plus emitter. If H plus is decreased in this reaction, what will happen? Right? In this reaction, if you decrease H plus, system is trying to increase H plus. අපි H plus අඩු කරොත් system එක try කරනවා. equilibrium එක try කරනවා H plus වැඩි කරගන්න. කොහොමද වැඩි කරගන්නේ? By favoring the forward reaction. Right? By favoring the forward reaction. So since the forward reaction is favored, sulfide concentration is increased. Right? ඒක නිසා එක වැරදි increase in pH solution decreases the sulfide ion concentration කියන එක වැරදි. එතන sulfide ion concentration increase වෙනවා. On the theory, Sarah theory, right? So when you consider pH, increase in pH will decrease H plus. So this will affect this equilibrium. If you decrease the amount of H plus, system is trying to increase the amount of H plus. In order to increase the amount of H plus, according to the Lecher-Leaf principle, this equilibrium is shifted to the right hand side. That will increase the amount of sulfide ions. That will increase the amount of sulfide ions. Then question number 31. Right, sorry, question number 34, the answer is 2, BC correct. Okay, so you can write a comment about that. Right? You can write a comment about that. We'll be moving to the structured essay paper soon. And then we are coming back to the discussions of MCQs. We have the time. So then this is the structured essay answers. Shall we check it? Right. So then this is the first structured essay question. Here 24 marks you have to add, right? 24 marks you have to add. So then check your answers from here. Tell me the difficult cases. $24 marks. That is 4 into 6, 24. Highest electronegativity, has an allotrope, conducts electricity, monoatomic, largest size, no p electrons but a stable s configuration, highest fascination energy, right, among the given elements, right? Second row in the period table here. Second row in the period table. Identify the element that forms mostly electron deficient trigonal planar covalent compounds. BCl3, BCl3, likewise. So out of 24, you can add your marks. 24 marks, right? Next one, draw the most acceptable Lewis dot dash structure. You get 6 marks for this structure. Right? Structure, you should draw the lone pairs also. Lone pairs then they are asking to draw 2 more dot dash structures for this molecule. Use unstable under unstable drawn structure, right? The unstable structure unstable 4 marks. I mean, you have to shift this location of pi bond to here to get the stable structure, and you have to shift the pi bond to here to get the unstable structure. Why this is unstable? Because oxygen is an electronegative atom. When it is getting a positive charge, that is unstable, right? So you have to comment unstable, you get 2 marks, and here 4 marks for this structure. Resonance arrow is not compulsory. Any issues? Just check the structured essay paper soon. So can put your marks at the same time. Put your marks at the same time. Right, next part. This table. Please check the table. 16 marks. All right, okay. So then any questions? I think you don't have any questions related to these parts. Out of 16 marks, you can get your answers, right? Any issues? Right. Yihanga, Isara, Matisha, Pasan, Anuda, Upani, Vidara. Right. So then the next part here, let's check up to this, right? Simple question answer. So then here pi bonds, right? Actually, pi bonds are not formed by hybridized orbitals. You have to write the atomic orbital. When you write the atomic orbital, you know nitrogen, the atomic orbital is the valence shell. Valence shell of nitrogen is 2p. Valence shell of carbon is also 2p. You have to mention that, right? For the terminal atoms, you can write either hybridized or unhybridized. For terminal atoms, you can write either hybridized or unhybridized, and that is simple. Okay. How are the two double bonds oriented in the Lewis dot dash structure? So always the double bonds means sigma bond and pi bond, right? Sigma bond and pi bond. Sigma bond and pi bond. So actually, when you consider the pi bond, it is perpendicular to the sigma bond. Right? Can mention this. Please check your marks out of 52. For 1B out of 52, you can put your marks. Double bonds are perpendicular to each other. Sigma bonds are linear, pi bonds are perpendicular. That idea, right? You get 2 marks only for that part, right? Only 2 marks. Give an example of a molecule or ion that has a similar orientation of double bonds. You can add a orientation of double bonds, right? Okay, molecule similar orientation here. That should be like carbon dioxide or NO2 plus. Only 2 double bonds. Okay. No lone pairs. No lone pairs, just 2 double bonds and linear orientation. Your example should not contain more than 3 atoms. The elements in your example should be restricted to the first and second periods of the period table. Lateral overlap, perpendicular to each other. Double bonds are perpendicular to each other. Partially. You have to mention not how the double bonds are formed, not how the pi bond is formed. Lateral overlapping means how the pi bond is formed. You won't get marks for that. You have to say how the pi bond is oriented with respect to the sigma bond. Should mention double bonds are perpendicular to each other. It is 52. Okay, check this one. Quantum numbers. This part. Right, any issues here? Now we know n means principal quantum number, right? So you can see here 3p. 3p means main energy level is 3. P means it is subshell. So we know L value is 0. අපි දන්නවා L value එක 0 වෙනවා S subshell එක. Right? L value is 1 for P subshell, L value is 2 for D subshell. ඒක දන්නවනේ. ඒ නිසා මෙතන 1 කියලා යන්න පුළුවන්. ඒතර මෙතන n එක 3 L එක 2 කියලා කියන්නේ ඒක 3D. Right? 2S. So then we know n value is 2. So then for S both L and ML is 0. Right? The melting point. මෙතන case එක melting point is proportional to the ionic character. The ionic character is proportional to the cation's radius. Cation's radius. Higher the cation's radius, higher the ionic character. මෙතන නම් cation එකේ radius එක ගන්න වෙන්නේ lithium potassium වල. Right? What about lithium and potassium? You can see potassium is having high ionic character than lithium. Anion is same because the cation's radius. Higher the cation's radius, higher the ionic character. Right? And then when you consider anion, it is the inverse of that. Anion එක කියන්නේ අනිත් පැත්ත. Right? Ionic character is inversely proportional to the anion's radius. Right? Anion's radius. ඒ නිසා එතනින් මතක තියාගන්න higher the anion's radius, sorry, lower the anion's radius, higher the ionic character. මේක ලියලා තියාගන්න. මෙතනදී ඒකයි මේ anionic radius එක අඩු වෙනකොට fluorine ගේ තමයි වැඩි කරන්නේ. ඒකෙන් තමයි answer ගත්තේ. Stability, you know, NF5 is not existing because it is not having octet, right? I mean octet is exceeded. Octet එක exceed කරලා නැති. ඒ නිසා NF5 කියලා එකක් තියෙන්න බෑ, very unstable. So then NO4 3- why it is having low stability? Because the charge, right? When you consider NO4 3-, the charge distribution is very high, minus, 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 plus. That's what it is, less stable. Bond distance, you can understand NOCl, this is how we draw, double bond. NO2F, there's a partial double bond. NO2F එක අඳිනකොට අපි ඇත්තටම අඳින්න ඕනේ resonance hybrid එක. මේක resonance hybrid එක අඳිනකොට ඔයගොල්ලෝ දන්නවා මෙතන partial double bond එකක් එන්නේ ඉන්න ඕනේ. NOCl3 අඳිනකොට පුතා ඔයගොල්ලන්ට එන්නේ NO වලට single bond එකක්. හරි. Single bond එකක් එන්නේ මේක plus වෙලා මේක minus වෙනවා. ඒත් බලන්න single bond එකේ bond length එක වැඩි than the partial double bond and than the double bond. හරිද? මොනවද issues තියෙන්නේ? හරි. C part මම ඔක්කොම ටික explain කරා. හරි. So you can put your marks out of 100. You can put your marks out of 100. Right. Next question. This one S block. Check your answers. Very simple question, right? You can answer good කියන්න දෙයක්වත් නැහැ. Check කරගන්න. The element is magnesium. Because of these ionization energies, we can predict this is group 2. The configuration: magnesium oxide, magnesium nitride. Solubility of sulfates decreases. Solubility of hydroxides increases. Thermostability, that is increasing. Right. So we know why thermostability increases, because the size of the cation. Right. So then when the size is increasing, the thermostability is increasing. You can say this idea. Right. Therefore, polarizing power decreases. You should write these terms, right? මේ 3 hari මේ දෙන්නගේ එක්කෙනෙක් තමයි ඉන්නේ. The decomposition of carbonates become difficult going down as a route. Decomposition temperature is increasing. Check it from there. Right. Next part. Identify the element in S block which features the similar manner with hydrogen and oxygen but does not belong to the same group as X, lithium, right? Another metal ion contribute to the hardness. Hardness can වතුර තියෙන කියුල් ගතිය. So then hardness is due to calcium and magnesium. Identify the compound most commonly used to improve the hardness of water, sodium carbonate. When you add sodium carbonate, calcium get precipitated as calcium carbonate. Sodium get precipitated as sodium carbonate. There are two types of hardness: permanent hardness, temporary hardness. Permanent hardness means by heating we can't remove calcium and magnesium ions. Okay, so then permanent hardness. Temporary hardness means by heating we can remove it. Temporary hardness is due to the calcium and magnesium as bicarbonate ions. Then the permanent hardness is due to calcium, magnesium existing as chlorides and sulfates. Right. So then green are reagents. So then you can put your marks out of 50 for this. This is question number 2A. So then organic chemistry වල මොකටද ගන්න කියලා අහලා තියෙනවා magnesium නේ. Right. Here when මේ species ටික මේකත් අපි අඳුරගන්න මෙතනින් you can see they are mixing these species. Right? They are mixing these species colorless with a pungent odor. Pungent odor means like SO2 and like ammonia. Protonic odor definitely H2S. Right? Reddish brown with a pungent odor. Right? Reddish brown gas means NO2. Right? NO2. ඒක අපි අඳුර ගන්න පුළුවන්. So actually when you add acids, right, ANE contains aqueous solutions of this. The characteristic of the solution obtained the gases on the addition of HCl. දාලා මේවට acids දානකොට මොකද වෙන්නේ? So for carbonate, when you are adding an acid, what will happen? See the reaction. When carbonate එකට acid එකක් add කරනකොට carbon dioxide gas එක evolve වෙනවා. පාඩම් කරගෙන ඉන්න. Nitrite එකට acid එකක් add කරනකොට NO2 gas එක evolve වෙනවා. Brown color gas එක. Right. මේකෙන් ඕන එකක් ලියන්න පුළුවන්. Nitrite එකට. B. C එක බලන්න sulfide එකට acid එකක් add කරනකොට තමයි H2S gas එක රොට් නැගෙන්නේ. Thiosulfate එකට acid එකක් add කරනකොට SO2 gas එකයි colloidal sulfur precipitate වෙනවා. Sulfur precipitate වෙනවා SO2 gas එකයි. හරි. හොඳයි check කරගන්න answers එතනින් තමයි අරගෙන තියෙන්නේ. ඉතින් chemical test ලියලා තියෙනවා CO2 අඳුරගන්න lime water වලින් pass කරන්න පුළුවන්. ඒකේ color එක milk pen. Right? White precipitate එකක් යනවා. හරි. ඊට H2S එකට lead acetate වලින් යවන්න පුළුවන්. ඒකත් එක්ක black color precipitate එකක් යනවා. එහෙම ලියන්න පුළුවන්. නැත්නම් තව test ගොඩක් ලියලා තියෙනවා. Check your marks. Okay, see the test. Okay, alternative sets are available. So I'll be adding a proper marking. I will be adding this marking scheme with this discussion, so you can download it and check it. Right. So here, third question. Let's check it very soon. Right. So then here the third setup. You can apply Q equal to MC theta. Just read the question. Samara by MX solid is dissolved in water. Like okay, sodium chloride dissolved in water. So then initial temperature of distilled water was 25. So then after adding this temperature was reduced to 70. So we know why the temperature is reduced. And temperature is because there's an exothermic reaction. Sorry, there's an endothermic reaction. In an endothermic reaction, it will absorb heat. So then the temperature is getting decreased. That's what's happening, right? Temperature. So then you can understand it clearly. Density and specific heat capacity of water are 1 gram per cubic centimeter and 4.2. Assume that the density of the specific heat capacity will not change in the dissolution of mx solid. Right? So then we are adding mx solid, the precipitate is getting dissolved. So then m, you can see 100 cubic centimeters into 1 gram per cubic centimeter. S 4.2, and this is theta, 3360. 3360. The answer is joules වලින් ගන්නවා. Right. 4 plus 1 means unit. Figure with 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 unit. Right. Next one. The dissolution of mx in water is an endothermic or exothermic. Definitely it is heat absorbed against endothermic. Let's say අපෙන් අහනවා මේක enthalpy change එක ගන්න කියලා. අපි මේ moles වලින් බෙදලා enthalpy එක හොයාගන්න ඕනේ kilojoules per mole. මොකද 0.1 moles of mx එකට තමයි මෙහෙම වෙලා තියෙන්නේ. Right. So for 0.1 moles of mx, we have taken this enthalpy change. So for 1 mole of mx, what is the enthalpy change? Right. So then 4 plus 1 for this figure, and then this 4 plus 1 for this figure. Right. And then this 4 plus 1. If this experiment was conducted using 200 cubic centimeters of water, would you expect the temperature change to be larger than the above value? Explain your answer. Right. Actually, this answer is an enthalpy change. Even you are using any volume, on a volume, enthalpy change. Enthalpy change means we are checking it for the amount of moles, not the volume. You know, when volume is increased, number of moles is not changed. Right? Volume increase moles වෙනස් වෙන්නේ නැහැ. වතුර දැම්මා කියලා. හරි. Temperature would be smaller, amount of heat is constant. The mass has increased, therefore the temperature change would be smaller. මෙතනදී temperature change එක තියෙන value එකකට වැඩිය අඩු වෙන්න පුළුවන්. Larger than the above value කියලා හරි no, it would be smaller කියන එක. And when you add water, the temperature, the heat will be absorbed by water. වතුර add කරනකොට heat එක absorb කරගන්න. වැඩිපුර water දෙනකොට heat එක absorb කරගන්නවා, so then the temperature is decreased. You don't get this much of heat change. That's the reason, right? And then show the variation of the system by drawing temperature time curve. So then starting from 25, they are moving up to 17. Then there is this decreasing, and then there's an equilibrium here. I mean the transition, right? Small transition, and then it is reaching to the room temperature. It's reaching to the room temperature. That means මේවට තමයි marks දෙන්නේ. Okay, just check correct shape. Okay. Just check your answer. Right. Question 3, 4, and 5. In this question, why a plastic cup is used in this instead of a metal cup? Because metals are good thermal conductors. When temperature is decreased, metal provides conducts and small surroundings. Plastics are poor thermal conductors and have low capacity. Right? The reason. Then the gives free energy of the dissolution they have given, and they are asking using the enthalpy change calculated above. Calculate the entropy change. I think equation apply කරන්න delta G not කියලා apply කරන්න එපා. මොකද මේක හරි. තියෙන්නේ 25 Celsius වල නෙවෙයි. Right? එමු නේද? හරි. So they have calculated as 26 kilojoules. Calculate the entropy change of the solution in water 25 Celsius. So make 25 Celsius using the enthalpy change calculated above. Delta G equal delta H minus T delta S, because you have used, we are using the previous cases. So in this system, you're using these temperatures. The methane enthalpy change again is 33.6. Right. So that's what you can't use this equation. So then, however, the S answer is joules moles per Kelvin. We'll be getting the S in kilojoules per moles per Kelvin. මේකේ answer කියන්නේ kilojoules moles per Kelvin. Right. මේකේ answer කියන්නේ kilojoules moles per Kelvin. You have to convert that answer to joules moles per Kelvin by multiplying from 1000. Right. By multiplying from 1000, you have to convert. That's the process. Joules moles per Kelvin. Would you expect the solubility of MX solid is increase or decrease with increase in temperature? So then when you add MX solid, okay, the solubility is getting but increases with increase in temperature because it's an endothermic reaction. Dissolution of precipitates is endothermic. So when we add these solids to water, it will increase the temperature. Right. endothermic. Okay, so then fourth question, this is a this question මේක තමයි දැනට අහලා තියෙන isomerism වලින් ටිකක් confusion වැඩිම තියෙන isomerism question 19 එක. It's very difficult to sort out answers because of less amount of data. Okay. Because of this less amount of data, at the beginning we'll be getting like 5 structures for these molecules. Okay, and structures පහක් විතර එනවා. So then when we want to filter the structures, we have to write entire reaction and all the reactions in the isomerism question in order to get the final products. මේ වගේ isomerism question එකක් දැකලාමනේ. මේ 19 isomerism question එක. But මේක හන්දා ඔයගොල්ලෝ හිතන්න එපා isomerism question සමහරව කියලා. 20 එක lazy, 21 එක lazy, manageable, right? We can do that. But this is very difficult, right? At this moment because less amount of data they have given. question එක හදපු කෙනා මේකේ data සෑහෙන අඩු කරලා තියෙනවා. question එක filter කරගන්න විදිහක් නැහැ. I don't know whether you have done it very easily. It's impossible, right? However, and question is manageable. At the end, these answers are okay. But in order to reach the answers, we should write all the reactions and we have to get more amount of time here, right? This isomerism question. So here, molecular formula C5H10O. So we know C5H10O means, according to our rules, that is CnH2nO. This is definitely aldehydes and ketones, right? So C5H10O, C5H10O2, C5H10O, CnH2nO. Yes, CnH2nO. These are aldehydes and ketones, right? So make an aldehyde ketone thamai structure same. They give orange red precipitate with 2,4-dinitrophenyl hydrazine. It is Brady stage. Then both aldehydes and ketones will give orange color precipitates with Brady's. When A and B are reacted separately in sodium borohydride in methanol, compound A gives C. A වලින් CN. Compound B gives D. Right. Compound B gives D. When C is heated with Al2O3, when you add Al2O3 to here, 2 alkenes, you get E and you get F. E F. When E and F are reacted separately with concatenation and the products are hydrolyzed, the compound E gives G. So make a hydrolyzed when you add concatenation. When E and F are treated separately with concatenation and products are hydrolyzed means actually dilute H2SO. Conc H2SO and hydrolyzed means adding bond. You make a dilute H2SO here. So you are adding dilute H2SO, so then alkene will be converted into alcohol. Right? Compound E gives G, I think dilute H2SO. Conc H2SO and hydrolyzed means dilute H2SO. F gives G. G gives stability immediately with the Lucas stage, and definitely should be a tertiary alcohol. Tertiary alcohol. So when it is giving a tertiary alcohol, you should identify it should be made out of a ketone because you want to get OH at the center. ඒ නිසා එක ketone එකකින් හැදෙනවා කියලා තමයි ගන්න වෙන්නේ. ඒ පැත්තේ G එක. එතන G එක අහලා දෙනවනේ. The Lucas H also gives the stability with the Lucas stage, but not immediately. But not immediately means like slowly. So it could be secondary alcohol.
secondary alcohol, and then this should be tertiary alcohol. ඉතින් එතනින් තමයි start කරලා තියෙන්නේ. tertiary alcohol, secondary alcohol. ඒ කියන්නේ G එකයි H එකයි ලියලා තියෙන්නේ. Right. F gives H. එතන මෙතනින් F එකෙන් compound F gives H. So F එකෙන් H එකෙන්. Right. ඉතින් F එකයි H එකයි ලියලා ඊට පස්සේ අපිට ACD ගන්න පුළුවන්. එතන අපි මේ A is related with this G. Right. A and B. So then you can write the answers in accordance with that. එකත් එක තමයි answers ගන්න වෙන්නේ. Should write the sequence. So first of all, check your answers. Check your answers. 5 times 2, 10 here. Here 5 times 4, 20. So then there's 30 marks for this. A gives C. C gives E, F. F gives G. Ne? So E gives D, F gives H. F gives H. So if we know G, we can get the structure of E. G එකෙන් E එකේ structure එක predict කරගන්න පුළුවන්. If we know H, we can get the structure of F. Okay. F and H. Picking H again. Then A and C. Right. So actually you get cis-trans structures. Make a cis-trans again, but here in E there's no cis-trans. F also no cis-trans. So then try to attend the question again and again. Lucas reagent. For tertiary alcohols, we get an immediate turbidity. For the secondary alcohols, we get a turbidity after certain minutes. Right? Primary alcohols, even after 30 minutes, we don't get a turbidity. Okay. And then check the next part. Draw the structures of BDI. D, L2O3, D gives alkane. I is filled with concrete SO4, hydrolyzed GSO. BDI. Then describe the reaction to distinguish A and B. So you know A and B, A is a aldehyde, and then sorry, B is a aldehyde, and then A should be a ketone, right? Ketone එකක් නේ. Right. So then in order to identify aldehydes and ketones, we can use these threads. Test tolerance reagent, silver mirror. Valence reagent, red coloration. Acidified dichromate, green coloration. KMNO4 decoloration. All these threads are applicable for B. මේ ඔක්කොම වෙන්නේ B වලින්. aldehyde එකෙන් ketone එකෙන් මේ කිසිම එකකට result එකක් එන්නේ නැහැ. Right? B gives these results and ketone will not give any of these results. Last part, structures of this. So then when you're adding acid chloride to benzene, it's an electrophilic substitution, and then you get this product. Then when you're adding Grignard to here, you know, when we're adding Grignard to here, CH3, C triple bond C, MgBr, this delta minus and this is delta plus, right? Negative charge carbon would attack to here, and this bond will dissociate. This bond will dissociate, so then you will be getting this after adding water. And water that anything, when you add hydrogen palladium barium sulfate chloride, is the last catalyst, the triple bond is converted to a double bond. Right? Concat to SO4. Keep remember, concat to SO4 means not direct to SO4. Right? So then what will happen? H is added to the carbon which is having highest number of hydrogens. In the other part, OSO3, H is added to the other one. Right? OSO3, H is added to the here. So then you get this one 5 times 4, 20. Out of 20, you can put your marks. Out of 20, you can put your marks. And then the last part here, the reactions, right? The reactions and the mechanism. Reaction 1, it's an electrophilic substitution, benzene acylation, right? Reaction 2, it's a nucleophilic addition. This is Grignard reaction, nucleophilic addition, and reaction 3 is electrophilic addition. Okay, check the mechanism of reaction 3, OSO3H. Right, okay. This is electrophilic substitution, nucleophilic addition and electrophilic addition. ඒක clear නේද? දැන් අකුණු 15යි 5 තුනක්. හරි. අන්තිමට මෙන්න mechanism එක මේ pi bond එක මේ පැත්තට break වෙන්නේ. අනිවාර්යෙන් මෙහෙට මොකද this is delta minus, right? This delta plus and then this bond is dissociated. මේ තියෙන්නේ sulfuric. Sulfuric තමයි කියන්නේ HOSO3H, right? And then here you get a positive charge and OSO3H is attacked into this, right? And you get this one. ලකුණු මෙතන මේ arrow එකට 3 මේකට 3 මේ space arrow එකට 3 මේ space එකට 3 මෙතන 3 and here 15 marks, right? So this is also accepted. So then however 50 marks for that mechanism, right? So then this is what we have discussed. This is conc H2SO4, right? Alkanes with conc H2SO4 and the alkanes with conc H2SO4 reaction, right? Okay, so we have finished the structured essay paper discussion from here. That is the entire part. So then when you put your marks for the structured essay paper, for the first structured essay out of 100, second structured essay out of 100, likewise get the marks out of 400. For the MCQ paper, get the marks out of 50. Okay, so then what is the homework for this week's session? That is essay paper, do all the 6 questions, 5, 6, 7, 8, 9, 10. You have to do all the 6 questions starting from 5 to 10. Then we'll be discussing all the 6 questions in 19 essay paper. So keep remember, this is the first MCQ paper of your syllabus. Sorry, first A-level paper of your syllabus. ඔයගොල්ලන්ගේ syllabus එකේ මේක තමයි පළවෙනි paper 19. So මේක directly related to the syllabus. Good syllabus එකේ නෑ කියන්න බෑ. So this is the first paper of your syllabus, right? So I'll be discussing 2 MCQs and finishing the session, right? So then can you tell me another MCQ to discuss in the MCQs part again, right? MCQs part again. So we have discussed many more MCQs in the today's paper. Now critical MCQ එකක් කියන්න. හරි. 38 39 discuss කරලා දෙන්න කියලා කියනවා. හරි. discuss කරමු. මේක ලේසි පුතා. මම 39 කියන්න නිකන් මේ. හරි ලේසි. මේ ඔගේ size එකට බලන්න එපා question එකේ. Volatile liquids A and B have saturated vapor pressures P0 A and P0 B हम कहते हैं ना මේ ideal solution. හරි. ideal solution කියලා තියෙනවනේ. Ideal means okay, what will happen, right? ඊට පස්සේ මෙතන දීලා තියෙනවා තව කේස් එකක් ඔන්න the equilibrium vapor pressure of the clouds are කියලා නේ ඊට පස්සේ saturated vapor pressures P0 and Pb. The vapor pressure of equilibrium and the clouds and when the volume of the container is increased the හරි volume එක increase කරනවා කියලා කියන්නේ. ඔව්. So actually when you increase the volume එකක් හොඳ question එකක් ඇත්තටම what will happen is imagine when you increase the volume you have this kind of a container and then the gases, and when you have increased the volume of the container the surface area get increased. Surface area get increased. For question 38, higher the surface area, higher the number of molecules that is moving to the vapor zone. Vapor zone එකට යන count එක වැඩි වෙනවා. ඒ නිසා හරි. So for question number 38 in this paper they have given answer as 3, right? What is 3? Statement CD correct. While some amount of A and B goes to the gas phase, compression of the liquid phase changes. Liquid phase එක change වෙනවා. While surface area එක වැඩි වෙනකොට we can get more molecules to the vapor zone. Because you know while some amount of A and B go to the gas phase, the compression of the gas phase changes. Right? Yeah. So then while some amount of liquid zone එකෙන් gas phase එකට reaction එක favor වෙනවා. මම කියන්නේ volume එක increase වෙනකොට container එකේ surface area එක වැඩි වෙනවා. ඒ නිසා තමයි CD අරන් තියෙන්නේ 38 එකට. හරි. ඒක එහෙම අපිට simple approach එකක් ගන්න පුළුවන් CD. Okay. 39 ඉතින් 39 එකේ answer එක අපිට දීලා තියෙන්නේ 2 කියලා. හරි. BC correct. Why? Conductivity of the solution increases when the concentration of weak acid decreases. Nah. Conductivity will depend on the concentration, right? Conductivity will depend on the concentration. Higher the concentration, higher the conductivity. ඒක හරිනේ. The conductivity of the solution increases when temperature increases. ඒක හරි. With the temperature වැඩි වෙනකොට kinetic energy වැඩි. Higher the kinetic energy, higher the ability to move ions. Ions and speed එක වැඩි වෙනවා, right? ඒකනේ conductivity කියන්නේ. Conductivity of the solution decreases, but the fraction of the dissociated weak acid increases as more water is added to the solution. උදා වතුර දානකොට volume එක වැඩි වෙනවා. හරි. So then you know N equal to Cv when you increase the volume, concentrations decrease, right? So you know alpha is equal to Ka over C. Oswald's dilution law, molar ionization coefficient.
When volume is increased, concentration decreased. When concentration is increased, when concentration is decreased, dilute කරනවා කියන්නේ concentration අඩු වෙනවා. අතර alpha වැඩි වෙනවා. හරි. ඒකයි වෙන්නේ. මෙතන fraction of the dissociated weak acid increases කියන්නේ. මේක හරි. fraction එක increase වෙන්නේ මේ විදිහට. හරි. අතන conductivity එක decrease වෙන්නේ ඇයි? concentration එක අඩු වෙන නිසා. Conductivity එක directly proportional වෙනවා concentration. Lower the concentration, lower the conductivity. හරිද? concentration අඩු වෙනකොට කෙලින්ම conductivity එක අඩු වෙනවා. හැබැයි conductive concentration එකයි molar ionization coefficient එකේ තියෙන inverse relationship. මේක Oswald's dilution law. Right? pH lesson. Lower the concentration, higher the alpha value. Right? When sodium chloride is dissolved, the weak acid solution conductivity decreases. Decreases නෙමෙයි increases. sodium chloride වතුර දැම්මම conductivity එක වැඩි වෙනවා. අර sea water වල conductivity එක වැඩි වෙන්නේ ඒක. ඔන්න 38 39 මම කතා කරලා දුන්නා. මෙතනත් 39 වෙලා answer එක 2 කියලා තමයි අරගෙන තියෙන්නේ. හරි. Okay 37 කතා කරන්න කියලා තියෙනවා. හරි. කියමු 3D block elements ගැන අහලා තියෙන. ඉතින් 37 වෙලා answer එක ABC correct. ABC correct. Right. IA zinc has highest percentage energy among 3D block elements. Ionization energy එක increase වෙනවා. හරි. Contrast the ions in the main group of elements. 3D block elements method rarely attain the noble gas configuration. And S block elements හැම වෙලේම noble gas configuration වෙනවා. Ng2+, Na+, K+, and neon වල නැත්නම් argon වල configuration එකෙන් තියෙන්නේ. But Fe3+, it is not attending noble gas configuration. Are nickel 2+, it is not attending noble gas configuration. That is very important. The 3D block elements that forms colorless compounds are titanium and zinc. We have more D block elements. Scandium colorless compounds හදනවා. Copper plus colorless compounds හදනවා. ඒ නිසා අපිට colorless compounds තියෙන elements කියන්න කිව්වොත් මේ ඔක්කොම කියන්නේ. හරි. ඒ නිසා ABC correct කියලා ගත්තේ. C එක මොකද්ද? Although the electronegatives of 3D elements are higher than the electronegatives of corresponding S block elements, the atomic radius are smaller than the atomic radius of corresponding S block. මේක හරි. Because electronegativity get increases across versatility. Atomic radius get decreases across versatility. That is continued even for D block. Right? It's a general trend. Right? So then ABC is correct. So then I have discussed those questions we have suggested in 31. So my request is please write a MCQ review. Right? MCQ review is essential. Write an MCQ review for all MCQs and send it to me. Right? I'll be sending an MCQ review with this session and the Sarasavi Pastor's book MCQ review. Then please write starting from beginning, question 1 to question 50. Then I'll do with the essay pen. Those are the homeworks for this week. And I'll be adding term test discussions to your WhatsApp group for the students who are seeking more questions and more discussions. Okay? That's it. Have a nice day.